Oh, Matish, there's a lot of background noise. Is it me or someone else?
Okay. I'll check. Give me a sec.
Yeah.
Oh, Matish, there's a lot of background noise. Is it me or someone else?
Oh, that was YouTube. So there's
It's actually me. It's us broadcasting on
So-
YouTube. Okay, excellent. So we are
Awesome.
already live on YouTube. So I
We're
will
famous.
copy the link, copy streaming link. So now I can actually send email to everybody, to all the participants.
Oh, can't hear you, Mina. I think you're muted.
So also TAs too. TAs start to ask me the link. So
Yeah.
we also need to send a YouTube link to the all TA.
So I'm just copying to all the link for today is at the bottom of the email. Okay, so I'm sending this to everyone. So hopefully this will work. Bordeaux.france is not a valid email address. So there is somebody in this file, Mina, that you gave.
I see. Yeah, yesterday Brent updated some emails, so I will update it.
Okay, so let me remove this for the moment.
Mm-hmm.
Okay, and then something else is not a valid email address. Okay, I will send anyways. So the person, I'll put it in Slack for you, Mina. The person who doesn't seem to have a valid email is this, so we need to update that.
Right, and we have one more participant this morning, so I also somehow updated. I updated and then I will send it to you. Okay, so
because the email's already offline for me, so if you can just give me the email, actually. Doesn't let me send the email because one participant has some kind of space. Okay, let me try it again. Okay. And you have, I see. So this is the person from Bordeaux, and then, yeah, cool. I'm adding those as well.
And one more. So
this F.U3, okay.
Yeah, these three, yeah.
Okay, and then, so in the past it would allow me to send even if one was not valid, and now it doesn't let me send anything. Okay, well, let's see what happens. Oh. I should have checked this more carefully, but I don't want to send emails. Okay, so I remove this. So this person is added. Okay.
I'll be right back.
Yeah, no worries. Just making sure. I just don't want the whole, email be held up because there is some space somewhere. Okay, let's see what it does. Okay, let me try again. Okay, space. Okay, let's try it once again. Copy, email, fingers crossed.
Yeah.
Okay.
Yeah, done.
Okay.
Kylie, you look kind of the ghost.
Yeah. Well, the good news is for Kylie, there's not much to do today. It's just kind of to show up in the beginning, right? And then Kylie, you can sign off totally. So,
I think it's the headphones.
oh yeah. Me too. I look like, my head is like twice my size with this. Okay, so let's see. Do you guys have the YouTube? So there's one undeliverable. What is undeliverable? Ottawa. Okay, so I see. So that was one. Kenny 012 at Ottawa is not found.
Can we, yeah. We can always post the link in the chat as well at the beginning as well, and people can pick it up if we can.
But it would be good to figure what's going on with this email.
It should be okay. Olga, I will send the updated, the tuned version after this.
So you have it in the email, right, Mina? So so I think this Ottawa, but I used the one that you gave me. So LKENNE 012. And it says could not be delivered. So maybe I should try without E at the end. Okay. All right. But other than that, I think the YouTube is working, right?
It is. It maybe about a 5 or 10 second delay. Does that seem?
Yes.
But not too bad.
Yeah, that is what we can expect it. Yeah.
Okay.
Right.
How's my background? Is there background noise? Does it sound okay?
Sounds perfect.
Yeah, it's good.
I have a fan running, so I don't want to.
So let's see. What I will do, I will just say, so Ryan, if you don't mind, like when we start letting people in 15 minutes, so if you don't mind projecting the first slide right away.
Yes. Yep.
And I will just say, and I guess we can all just have our video on just for first couple minutes. We'll say we have some instructors, and I will just explain the kind of logistics of the Zoom.
That'd be great. Yeah, great. And if you want to sort of introduce everybody or whatever.
Sure. Exactly. But then, Mateusz, I think what we will do, your group will just tell them, your group just goes straight into your room, right? They don't need to listen to Ryan. So you'll just sign off right away and you go there. Ryan, you don't need to share it now. We can wait 15 minutes.
Yeah, no problem. Let me ask you, for size, how does this, I'm going to be sort of switching back from the slides in RStudio. Is that readable or is it pretty small?
Smallish?
Small.
It's small.
Yeah. So it's readable, but 3 hours of that, I think, can be tiring.
Okay. How about that? A little better?
Yeah.
It's better.
It's better. Okay. Yeah, it's always okay. Great.
And so, Ryan, I will tell everyone that they can actually stay with the TAs and just listen through.
Sure, that would be
YouTube,
great.
Right?
Yep.
So it may happen that your room will be actually very small. You will see very few participants, right? So it will feel weird.
And that's fine because they can ask sort of questions on the fly and so on. I think that would be useful. Yeah, no problem at all. So now there are going to be times I'm going to cut. Well, actually, I will sort of explicitly cut for exercises, and there'll be some time where they'll be working with the TAs. And they'll be sort of quiet in here. So. Yeah.
So let's see. Anything else? So Mateusz, if there are questions, I think there may be questions like group 20, so they will need to remember who is group 20, right? So maybe that's just a bit, if they didn't pay attention to the number of their group. Maybe it will be good to post your Zoom link in the chat, maybe later, no, not right now necessarily. But I think that's it, right?
Yeah, and people, oh, you're muted. We can't hear you. Were you speaking?
Who, Mateusz? Or...
Yeah, I think he was. Yeah.
He's not muted, doesn't look
no,
muted
it doesn't
on my side. Yeah. Mateusz, can you say something just so that we can?
Yes, can you hear me?
We can hear you, but now there is probably YouTube in the background. So what I do, I just pause the YouTube and then I just refresh the browser whenever I want to go back to it. Because otherwise it's very noisy.
Olga, about the polls.
Yes. Oh yeah, let's take a look.
Will you be able to fire those off every so often, or how will that work?
No, I think it's best if you can do it. So
Okay,
let's take a look. So
Yeah.
at the bottom, so I guess, Matish, if you can mute the YouTube or whoever is doing it now, I think. Yeah, thank you. So see, so you have
cool.
questions. So this is one, and then like people will start responding, and then you would say end poll. I am not sure if the result is visible to everybody or not. You can just read off.
Oh, I can share it. Yeah.
Mm-hmm. Oh yeah, there's a share results button here. Here you go. There was, yeah. Okay. Oh, and the other thing, let's practice that as well. I think that will be useful. And also for Kylie for tomorrow, it's the same thing. So if we can just remove that. So what we usually do, like the chat, we use it just for, you know, like, yeah, I can't hear, or where is the link, things like that. But then Q&A. So unfortunately, we don't have attendees now. So yeah, thank you, Kylie. This is good. So there will be a question in this Q&A.
Ah, okay, I see it. Yeah.
And so once the question will appear, you can have a dismiss button, meaning it will be moved to the dismissed panel, meaning you don't have to worry about it because, you know, it's not relevant or you answered already.
Okay.
And then you can have answer live. So you click on, so there will be answer live, just click on this button. And once you done answered live, it will move to the answered column.
Okay.
Or, for example, if you have a break and everybody's with the TAs, you can answer in writing. So once you type an answer, it will also move to the answered column.
Okay.
So essentially, the open will be only the questions which were not, you know, acted upon. So
got it. Okay.
They were not dismissed, not answered live, and not answered in writing.
Got it. Okay. Yeah, I'll see that. And we have some time for, or I save some questions for time for questions at the end. So maybe stuff I can't get to, I can just sort of queue it up and deal with it at the end.
That's
perhaps.
Right. That's right. And so I will also say that they should go to the TAs, but they can also stay with you during the break, right? Whenever you announce like the hands-on time.
Yeah. Okay. Yeah. Good idea.
Mina, if you don't mind emailing, I don't have all the TAs' emails separately. If you don't mind emailing them, that we will start at the hour. And so if they can already get ready, like watching the YouTube and be ready at their Zoom links. Like.
So they should be ready everything before 12, right?
Well, I think because the first like few minutes, there won't be much for them to do. But if they can be ready around 12 and already watch the YouTube link. Oh, okay. Thank you for the new email for this person from Ottawa. Okay, cool. So I will change that. And I think I got rid of all the spaces in that file. So I think we're all set.
And by the way, already 14 people are watching.
Really?
Yeah.
Like us speaking?
Yeah.
Okay. Well, then in this case, I guess we can already let people in if everybody's watching on YouTube. Let's do that. Okay, then I will start broadcasting.
So Olga, when I present, oh, I see. Okay. Yeah, I can see the interface down here. Okay. Yes. Everybody can hear me now. I was going to keep this version so I can jump back and forth between the slides. Is this big enough? Is this visible? Okay.
So everyone who is joining us now, welcome. So we will be starting in a few minutes. We'll just wait for the hour. So you have the YouTube link and you have the Zoom interface. So while we're waiting, please make sure that you can have access to the GitHub repo and things like that. So we'll start at the hour.
And I'm going to post links in the chat to the slide deck in case you didn't get that. And also, we're going to be using RStudio Cloud. I don't know if everybody has signed up for that, so I'm going to post some links in here for you to sign up for RStudio Cloud.
So if you're just joining us, welcome. So we're still waiting for quite a few participants to join. Meanwhile, you can take a look at the chat window. So we have posted the link to YouTube. We also posted the link to the slides and some details for the RStudio Cloud, if you haven't done that yet. So if you're all set, just wait a few minutes. We will start at the hour. Hello once again. So we're still waiting for some of the participants to join. So if you're just joining us, welcome again. So in the chat window, we have posted a few links, how to locate the live stream YouTube link, how to locate the RStudio Cloud, and the GitHub repo if you haven't seen this already. If you have any questions as far as logistics, please don't hesitate to type them in the chat window. And if not, just wait a few more minutes. So we still have to wait for roughly half of the participants. So we'll just give it a few minutes. So the links are the same as in the email that we sent to everyone. So this is just redundant. So if you have seen the information in the email, you don't need to worry about anything. It is all the same. This is just for your convenience. Okay, I think we will go ahead and get started. Let me welcome once again everybody to the fall workshop on R fundamentals and best practices for mass spectrometry data analysis. We are very excited to have this opportunity. So this workshop is hosted by the American Society for Mass Spectrometry in collaboration with Northeastern University. And this is our attempt to do some work around R and practical issues around R in an online format. So this is our very first online attempt to a hands-on work and practical work, and we hope that it will go well. So, and if not, please let us know if something is not working as planned. So we have a fantastic group of instructors. So the question is, if will the workshop be recorded? Yes, it will be recorded. And let me start recording right away. So here we go. Here we go. So now the meeting is also recorded for everyone who will not be able to view it live. So we have a fantastic group of instructors. So let me introduce everyone. So my name is Olga Vitek. I am a faculty at Northeastern University, and I'm one of the organizers of the workshop. Our co-organizers and co-instructors are Ryan Benz from SEER. So Ryan will lead the discussion today. So Ryan has very extensive experience in teaching R and working with R in general, and specifically in relationship to mass spectrometry and proteomics. We are very fortunate to have Ryan with us. Another instructor for today is Mateusz Staniak. So Mateusz is a PhD candidate at the University of Wrocław in Poland. So we have an international team here, and Mateusz has also been doing a lot of work teaching R. So tomorrow we have our instructor is Kylie Bemis. So Kylie is a faculty in the Curie College of Computer Sciences at Northeastern University, and Kylie has made important contributions in R in general, and also in developing software and R-based software and tools for mass spectrometry. And so Kylie is the author of the Cardinal package in R. We also have Mina Choi, who will lead the discussion next week. So Mina is currently is a research scientist at Genentech, and Mina also has made very important contributions to developing R-based software. So Mina is the lead author of MS Stats, and she previously was at Northeastern University. And at the very last day, the discussion will be led in part by Mina and in part by Melanie Foll, who is a scientist at University of Freiburg in Germany. So we're very excited to have this team of instructors who will all contribute different aspects of this program. So, and of course, the important thing is that we have a large group of teaching assistants who I will introduce as a group shortly. So the very first thing to tell you is how we will get organized logistically and how the workshop will proceed in the next 4 days. So we will have two ways of doing things. The first is that we will have essentially lecture formats in this webinar as we have right now. And so today this webinar will be led by Ryan. And these webinars will have very short periods of time, like 15 to 20 to 30 minutes, depending on the topic. And at that time, you will have to do some hands-on work and have some exercises. And especially those of you who are just starting with R and have not done any work with R, we expect that there may be some practical challenges in terms of, okay, how do I get set up? How do I do the exercise? Is my answer correct? And all of that. And so to do all this hands-on work, we created breakout groups, each on its own dedicated Zoom link. And at each group, we have a teaching assistant who is familiar with the program, familiar with R, and is there to help you with all the hands-on questions. And so the main webinar will be primarily lectures and examples. And every so frequently, you would essentially leave this webinar, you will log off this webinar, and you will go to the Zoom link which was sent to you in the email. So this is the Zoom link specific to your group. We tried to make groups very small. Between the smallest will be 3 to 4 people. And we tried to make the groups as similar in skills and prior experience as we could tell from the online form that you filled in. And so at the same time, you have the YouTube link. So even though you're going to the breakout room with your teaching assistant, you still have the YouTube with the main webinar. So the YouTube will be always on this main webinar. And so you can go back and forth 15 minutes with hands-on and come back to the main room, or you can just stay with your teaching assistant for the duration and just watch the presentation on YouTube. So if you stay with YouTube, it's more difficult to ask questions to the main instructor. However, your teaching assistant may as well be capable to answer this question. So we will see how it goes. So because we have 100 participants in total, we felt like it is very difficult to answer detailed questions in the main room. So we hope that the breakout rooms will allow us to do really personalized and hands-on help, especially for those who are just starting. And so therefore, I would like to extend a very special thank you to to over 20 teaching assistants, primarily from Northeastern University, but also from other places, who made available their time to help us in this attempt. So we will see how it's going. So we really hope that this will be a very kind of hands-on and very interactive experience for all of you. So this is all I need to say right now. So maybe just the very last thing is Ryan now will take over and talk about the logistics as far as RStudio and so on. Very shortly after that, if you are group number 20, so this is the group who has most prior experience with R. So this group will sign off right away, and you will go directly to the link to Mateusz's room. And so Mateusz will lead a separate discussion for those who are not complete beginners in the group. So Mateusz, if you want to say just a couple of words about that. Yeah, and Mateusz just posted the link to the Zoom. So this is all I have to say. So let me welcome Ryan, and then Mateusz, if you have any comments before everybody from group 20 moves to your room, please do. If you don't know which group you are, check the email that was sent to you. There is a group number in that email.
Great. All right. Well, thank you very much, Olga. Thank you for that nice introduction. Like Olga said, I think we were hoping to all be together in the same room. That obviously helps for these kinds of classes to be able to see you, interact with you. Unfortunately, given the conditions, we haven't been able to do that, but we're going to work our best to give a great workshop here to get you started with R. In the chat, we posted a few links. I just wanted to, for people that have just joined, we have links to the slides there. Please go ahead and download those so you can refer to those. I have some code snippets in there that will be useful for the exercises. And then in particular, we're going to be using RStudio Cloud to give you an environment to work with R. If you haven't yet signed up for that, again, the links are in the chat, and maybe we can repost those again if they have some new people joining. Essentially, you just need to create a free RStudio Cloud account. It should be very quickly to sign up. And then you need to click the additional link to join the workspace. And I will show you a little bit more about that shortly. Great, so let's get into it. Today, I'm going to be covering essentially an introduction to R and some fundamentals of working with data. R is obviously a huge ecosystem. There's a lot to learn. We can't cover everything in a workshop. But we're going to do our best to sort of give you an introduction to writing R code and some fundamental ideas to get you on your way. You can also see that we're going to be covering some other things here. So after today, we're going to be looking at some data visualization with Kylie. Tomorrow, that should be great with ggplot2. And then in the following week, we're going to be working with Mina, who's going to be talking about some basic stats and doing some reproducible research. We're going to talk about using a really important package called R Markdown to talk about making reproducible data analyses and reports. And then the last day, that should be really fun. We're going to have some awesome authors of mass spec packages that are right here with us to present their amazing work and how that can be used in mass spectrometry data analysis, and hopefully should be a really nice sort of intro to using R to do very specific mass spectrometry things. I just wanted to, yeah, please go ahead, Olga.
First, a couple more logistics because there are some questions going on here with logistics.
Yeah.
So first of all, the room number 20. So there are several questions about logistics, right? So how do we know our group number. So this is an email sent on Thursday. So the email was titled ASMS Fall Workshop Logistics and Login Instructions. So the only group who needs to do something different is the group number 20. So this is the group who has, so what Ryan will do, he will really do the introduction, the very basic introduction for R. We had several participants who actually are not beginners. And so those will go to a separate group with Mateusz. Everybody else stays here. So if you are a beginner, don't worry, you can just stay here, right? If you are not sure which group you are, so you can look into this email. So the second thing I forgot to mention with logistics is that they have two ways to interact with us. So the chat and the Q&A. So as you can see, the chat kind of becomes a little bit, multiple communications here become intertwined. So I think that let's use the chat only for things like I can't hear, or something like that. If you have questions regarding like what we discussed, please use the Q&A button at the bottom. So the Q&A button at the bottom will be more effective because it allows us to triage the questions, and if they're answered already, we can move them out of the way. So it will be much easier to communicate for us. So if you don't mind, starting from now, any question regarding like R and anything that we discuss should go to Q&A, and the chat would be questions, for example, to me in terms of logistics, right? But everything else for R, let's use Q&A for that.
Thank you, Olga. And if you can kind of watch the Q&A, or maybe Kylie, some other watch the Q&A, and go ahead and interrupt me at any time.
I will take care of that here. So
thank you. Sounds great. Okay, so let's continue here. I just want to say a few words about R in general and why we're doing a workshop on R. R is a great language for doing data analysis work. And that's not to say that other programming languages aren't great either. For example, C, Java, Python, these are all considered a general purpose programming languages. They can be used pretty much in any domain. R is not a general purpose language, but that's really cool for people like us, for scientists, because it was developed from the very beginning to work with data. And so how it's designed, how it's evolved, how it's matured has had data in mind as a first idea. And so it really makes working with data a lot easier. And so it's a great choice that you chose to learn R. I know we all love it here, all the lecturers here, and hopefully you can start to learn R as well. Now, one thing I will mention that there is a learning curve to learning R. So I would say about 10 years ago, it was pretty challenging to learn R. It just wasn't as mature of a language. There weren't as many resources available. The community wasn't as big. And as a result, sort of your expertise in R as time proceeded was, particularly in the beginning, pretty slow and flat. And eventually you get over a hump and you start to learn things, and then you feel a lot more comfortable with R. But this was a really long stretch of time to get comfortable with R. And unfortunately, if you jumped into R, then you may decide to sort of quit somewhere along this sort of this low phase here of learning R, and it could be frustrating. Fortunately, if we fast forward today, I think there's a lot more resources for us to work with. And really that comes down to the fact that data is so important today. Data is everywhere. It's in every industry. It certainly is in science. Obviously, as scientists, we all deal with data every day, but it's also in pretty much any industry. Everybody is working with data now. And interestingly, R was kind of a small language 10 years ago, but because data has become so important, it's now a really popular language, and particularly in the data science field. In any of the sciences, R has been really popular. And so as a result, we have a lot better resources. We have a great community, just lots of things to work from. So I would say you've made a great decision to try to start learning R now, because it's really a great time, because it's a really great community and there's lots of great resources. That being said, it's still going to be a little bit of a challenge, but I'm going to say that it's worth it because it's a really awesome tool to have on your tool belt to be able to work with data. I just want to note that it's going to be frustrating at the beginning. R can be a little bit quirky, particularly if you know other programming languages. There are some strange syntax quirks, but what I'm going to recommend is please stick with it, try to get through the initial learning curve, and then I think you'll really learn to love R like many people, myself included, do after they get past sort of the initial hurdles. And we're going to try to help you along that process today and throughout this workshop. We're not going to cover all of these things, but just as sort of a preview for the future as you get more into R and more advanced, there are just so many aspects of the R ecosystem that are really cool for doing data. So there are a bunch of these different R packages that can help you do really cool things. We're going to be talking about ggplot2 tomorrow to do data visualization. In my opinion, this is one of the most powerful data visualization packages that exists today. We're going to be talking about this dplyr package a little later today for doing data analysis pipelines. We are not going to talk about this right here, Shiny. If you've ever wanted to build interactive web apps, R has a framework for doing that called Shiny. That's definitely more advanced, but it's really a great tool for sharing data in interactive web applications. We are going to talk a little bit about reproducible reporting in R Markdown next week, but that's another really key piece. So when you learn R, you can also look forward to all these other really cool things that come along for the ride in the R ecosystem. So very quickly, this is a very kind of rough schedule of what I'd like to try to cover today. I have times here, but we're going to have to be kind of flexible as questions come up and so on. But what I'd like to do is we're going to start off talking about working with RStudio. This is a program that we can use to help us write R code and work with R. I'm going to show you how to do that, as well as RStudio Cloud, which I've talked about. We're going to have a little exercise here, but we're going to stay in the main room for this exercise because I'm going to need to show you some things on RStudio, the desktop version, about making RStudio projects that I want you to learn. After that, we're going to start talking about R coding and R syntax. And then after that, we'll have a practice session. You will then move to your TA room if you haven't done that already, and you can work through some exercises that I've prepared to practice. We're going to talk about how we can read data into R. And then we're going to take a short break, hopefully around sort of the 1:30. We'll see how that goes. And that may be a little bit shorter or longer, depending upon the timing. After that, we're going to be talking about working with tabular data. This is just a really important thing for any kind of data analysis. In particular, this is a data structure. I'll talk about that, called a data frame. We're going to talk about how we can work with those and work with those in R. We may skip this topic here. I wanted to talk a little bit about the idea of tidy data. If we're running out of time, my slides are in the deck and you can look at that. But we may or may not skip that depending upon timing. This last piece I think is going to be sort of the interesting piece and certainly the most intense piece that we cover today. But we're going to talk about how we can work with data tables and a package called dplyr to do data manipulations, do data operations in a way that is, I think, straightforward to write and straightforward to read. And you can actually do some pretty powerful data analysis steps with a relatively small amount of code. And we'll have some exercises after that. And then we'll recap. Great, so any questions have come up so far?
Ryan, maybe I can add something because there were a couple of questions in the chat and in Q&A. So several participants were asking about the level of the course, right? And so what prior exposure is needed. So the workshop was intended for very, very beginners. So for people who have not worked with R before at all, right, and do not have any prior exposure. It turns out that it's not exactly the case, that some participants actually have some prior exposure, but at different levels. So what we tried to do is to create those breakout rooms for which you have the links, where everyone is grouped like roughly by the same level of prior exposure that you had. So this group 20 that some people asked, we had several people who were actually really advanced. So I think it just didn't make sense for them to learn about, basic data structures in R. For everybody else, so even though you think that you have done some work in R and you know how it works, we hope that the discussion in this main room will be more useful to you. And what you can do when you go to your breakout room, you can ask questions at your level, essentially. So if the main presentation is too basic, you can essentially ask your teaching assistant, okay, how can we expand on that? How can we do things more complicated? And the TA will be able to help you. So even if you feel like you have done already some R, but the material is very beginner, make sure you take advantage of your teaching assistant and ask them questions beyond what Ryan is talking about.
Great. Yeah. Thank you very much. Okay. Okay, so let's get into it here. Let's start doing some things here. So the first step is, if we're going to be writing our code and executing our code, we need to have an environment in which we can do that. And we're going to be using RStudio, and very specifically RStudio Cloud. And I also want to cover a component that underlies that, known as RStudio projects. And I'll tell you why those are important in just a second. First, there's lots of R's. I'm using lots of R's here, and I want to make sure people understand what we mean when we talk about it. We have R, we have RStudio, and we have RStudio Cloud. If we think about R is an open source programming language. Think of it as the system that allows us to execute our code and do work in R. If we use a car metaphor, you can think of R as like the car's engine. And we can contrast that with RStudio. RStudio is not R. There's no engine to it. It's just something that sits on top of R. It's known as an integrated development environment, or an IDE. Essentially, it makes it easier to work with R code. You can type code in there. You can execute R code. You can see plots. You can do lots of other things. So RStudio is not R. If you just download RStudio by itself, it will complain to you and say, hey, I don't see R installed on your system. So what you first need to do is install R, and then you would install RStudio on top of it. And then from there, we'll be using RStudio, or actually RStudio Cloud, to actually type our code, to execute the code, and to look at it. If we move all the way over to the far right here, RStudio Cloud essentially wraps up R and RStudio together and makes it available on the web. So you don't actually need to install anything. You just need a web browser to access RStudio Cloud. And if you do that, and I'll show you how we're going to work with this, but essentially you can get a working version of RStudio with R installed, and you can start writing and typing and working with code right away. Okay. Okay, so now let's talk about RStudio. So let's say you have RStudio installed on your system, or we're using RStudio Cloud. When you first open up RStudio, you get a window that looks like this. It doesn't look too impressive, but there's a few window panes here, and these window panes are going to help us get our work done. One of the most important is on the left-hand side here. This is the console. This is where you can actually type R code out and hit return, and it will execute that code and show you the results. And this is a great place to try things out, to type the code, see what happens, play with R, and so on. In this upper window, this is the environment variable. Don't worry about this panel for now. We're not going to cover that today, but as you work more with R, this can be more and more useful. In the lower right corner here is a file browser. This works just like a file browser on your computer. If you want to open up a file, you can click on them. If you want to browse files, you can go through there. There's another window that's really important, and you don't see it when you first open RStudio, but it's called the editor. And you would get that, and I'll show you how to do this, but you would go to File, New File, and make an R script, and that will pop up this new window pane here. This is the editor. You can also type R code in here, but what's really important is you can actually save this code to a file. And I'm going to explain why that's really important here in just a minute. For this course, we're really just going to focus on these two window panes. There's lots of tabs here. You can see there's lots of menu items here. So there's actually quite a bit of things here. It may be a little intimidating, but to start, we're just going to work with these two main panes here. And let me talk about some of the difference between the console versus the editor. So the console, like I said, is where you test, experiment, practice the R code. You can think of this like a sticky note or a cocktail napkin. It's great for taking quick notes and seeing things, but the problem with those things is that they could go away at any time. There's really no real good way, I would say, to save the code that you type in the console. So we contrast that with the editor. That's where you can write code that you want to keep. You can save that to a file. And in particular, you save that to a file called an R script. It has an extension .r at the end. And essentially that allows you to save your code. And I would recommend that even if you think you're just playing and this is just throwaway code that you don't care about, it's still a good idea to write it in the editor and save it, because you never know if you might want it again. And if you don't want it, it's easy just to throw away that file. So there's really no downside to working in the editor and saving your work as you go. Okay, so that's a little bit about RStudio. I'm going to bring it up in just a minute and show you what we're going to, how we can work with it. But I also wanted to point out this idea of RStudio projects. An RStudio project is essentially just a directory with a special file in there that RStudio can read. And it essentially allows you to organize your work. So it makes a lot of sense if you're going to do a data analysis that you want to keep that organized. An RStudio project is the way to do that. So it helps you organize things. It also helps you deal with this issue of dealing with file paths. This can be a really confusing thing, particularly for beginners. Let's say you downloaded a data file from the internet and it's somewhere on your computer, but you want to read it into R. And you have to figure out how to tell R where that file lives. And that can be kind of confusing and frustrating sometimes. But with RStudio projects, if you dump your data into the directory, the project directory, it's very easy to access that data. And so RStudio projects really make it easy to work with R. Okay, I have in my slides here, I have descriptions of how to create RStudio projects, but I want to just do that live for you. This is a little different from RStudio Cloud. We'll get to that in just a second, but I want to show this to you so you are familiar with making RStudio projects on your own computer, for example, after the workshop when you work with R. So the first thing you want to do is you want to open up RStudio. Actually, let me do this. Open up RStudio, and we're going to get this window like I showed. It's loading up here. It looks like this big sort of blank window here. Okay, and we're going to make an RStudio project and start working from that. So what you want to do is you go to File, New Project, click New Directory. This means we're going to make a new project directory. You have to click New Project again. There's lots of things you have to click, unfortunately. The next thing you want to do is you have to say where you want this project directory to go. Let's just put it on our desktop, and we give it a name. So let's call this test project, and we can create the project. You see R kind of is resetting itself right now. Essentially, it's opening up this new project. And if we look at this file browser here, we can see that we've transitioned over into this R project directory. I'm going to show you how to read data files in just a minute, but imagine we have let me hide the presentation so you can see RStudio. Let's imagine that we have a data file that we downloaded off the internet. We can go to our desktop where this test project lives. We could take a data file here that maybe we downloaded. And if we just copy it into our project directory here, we can see that it appears here in our RStudio project. I will show you how to read a data file like this. This is another section, but we could do something like this, read.csv, and give the name of the file here and hit return. And we can read that file. Oh, this one's going to take a little while, but we can read this file into R and we can work with it. Okay, so that's how you make an RStudio project. I suggest that you always make RStudio projects when you go to work with data in R. Okay, and here's the data that R read. Okay, let me now go back to our presentation here. I would now like to cover working with RStudio Cloud because that's what we are going to work with here. So hopefully everybody at this point has joined the RStudio Cloud workspace for this project. If you haven't, sorry, Olga, it looks like there's a question.
No, I was thinking maybe it's a good time to have a poll and see if everybody.
Let's do a poll. Thank
yeah.
you. I'm going to do a poll here. So let me ask. Let's see here. How about stop sharing this? But let's ask the presentation's speed. Let me try this. Continue.
Yeah.
How was the presentation speed?
So on everybody's screen, you should have a poll. You just click on, yeah, exactly. So if it's too fast or too slow. Okay. And this allows us to have a feedback from you as a larger group, at least allows us to see a little bit. Okay. So if it is too fast already, I think it may be not a bad idea to go to your breakout room sooner. So you can still watch what is happening here through the YouTube, but at the same time, you can ask more detailed questions in terms of how to open a project and all of that with your teaching assistant. That's exactly what it is for, right? Because we try to balance, right, different skills and different speeds.
Great. So looks like we have a good sampling of the group here. Let me end the poll and I can share the results. So it looks like people are saying just right. So, okay, that sounds good. Like Olga said, if it's a little too fast, feel free to go to your TAs and ask them for some additional.
And Ryan, there's a few questions in the Q&A box for you.
Okay, great. Should I, let me see if I can bring those up. Okay, so, so one question is about using RM for the project. Is that something that is recommended? I would say, let me answer this live. Don't worry about RENV for the project. I think that's a newer kind of thing, so don't worry about that. Somebody asked, I tried to click a new project and it doesn't show anything. I would ask you to maybe talk to your TA about that. You can share your screen and they can see what's going on. Was the file sent to us to copy? Got it. The file is in the RStudio Cloud workspace there. Don't worry about doing this particular exercise. I think you can see this on the screen right at this point in time. I kind of showed you how to do it live. You can practice with that later on your own or with the TA. Okay. Okay, I would like, and then somebody asked, I would like to ask something regarding the R project. What is the difference between a new R project or set WD? These are two ways of dealing with file paths. I would say using an RStudio project sets your working directory for you. So you can accomplish the same thing with set WD, but I would recommend using RStudio projects as a way of managing that working directory automatically. Okay, and if you have questions, go ahead and follow up with your TAs. Okay, so now I want to show RStudio Cloud real quick here. So click on that link, the workshop link that I sent you, and you're going to see some projects here. This intermediate track, that's that extra group that's going to do the more intermediate R. We're going to be working with the introduction to R. So in this interface, all you need to do is just click on this link here. And what it's going to do is it's going to get a project set up that's going to have our exercise files, the required data files that we're going to be working with. And you're going to have your own copy. So don't worry about screwing up other people's things or deleting files or something like that. We can help you with that. This is going to be your own copy of the project. It takes a few seconds to deploy this. This is all in the cloud. So the cloud infrastructure is going on here. But once we get here, we have an interface that looks a lot like, in fact, it's almost exactly the same as what we saw in the RStudio desktop. Okay, so this is what RStudio Cloud looks like. And we're going to be working with these exercises here, not right at this moment, but shortly we are. And you'll be using this to write your R code in. Okay. Great, so let me, I'm going to get a sort of a scratch space set up so I can type some code in live here for us as we go into the next sections. Okay, great. Let's see, is there any other Q&A? I guess not. Okay, so now we're going to move on to the next steps here. And this is where we're going to start actually talking about our code here. And we're going to go through quite a bit of material here. There's code in the slides that you can copy and paste and work on your own after the course to get additional practice, as well as you can work with your TA to practice these things. Looks like we have another question here. Let me take a look. Okay, yeah, so great. So this was a question about somebody trying to open up this input CSV file. This is actually a pretty big file. Don't open that file right this second. And I would say probably it's great. I love to see people going to start working with the workspace already. If I could ask you just wait a little bit. We have some scripts here that we're going to be reading this data files and things into R that we can work with. And we'll work with that in just a minute. Okay, so we will be able to read this data file shortly. Okay, great. Okay, so now we're going to talk about some R code, first steps working with R. So what I'd like to do here is help you understand how we work with R and how you do things with R. And through that, we're going to cover some R essential syntax. We're not going to be able to cover everything. R is just too big to cover in a one-day workshop session or even a single workshop. But we're going to get you on your way to learning some essential syntax so you can start doing some hopefully interesting things, even with your own data after this workshop. In particular, we're going to talk about how to work with variables, vectors, and then conditional expressions. And then we're going to talk about some essential R functions that we can use to work on these kinds of data structures to do some pretty simple, but also hopefully useful things. So I just want to make a comparison between tools you might have used in the past to do data analysis and R itself. You probably have used Excel to do data analysis. You've probably used software that your mass spec vendors supply to you to analyze your mass spec data. Most of these programs are known as GUI programs. They have graphical user interfaces. And that means you do a lot of pointing and clicking. There are menus where you can select options. You can select icons and click on buttons to do things. And a benefit of that is that it can be very intuitive. You can look at the interface and it can help you, guide you to do the things you want to do. Let's contrast that with R. Everything you do in R, you interact by actually writing code. So you're not necessarily clicking on buttons to get things done. You actually write code to do stuff. So for example, in Excel, if you want to read a data file, you can click on data and you can import data, and there's a little sort of window that will help you look at the format and the structure, and you click import and then it will import that. You would do that same thing in R, but you would write code to do that. You would type out code to get that exact same thing done. So code is about, writing code is about doing lots of typing as opposed to lots of pointing and clicking. It may seem like particularly if you're new to coding, it might seem like that's a step back. It seems like the GUI is the way to go, right? It's more intuitive. It's something I can pick up easier, but there are actually several advantages of working with code. I've listed some here. I won't go into all of them, but I think this first point is really, really important, that when you write code, it explicitly captures everything that you do. So if you write all of your analysis in a R script, you could come back to it 6 months later or a year later and understand exactly what you did. And compare that to a GUI program. You would have to remember all the buttons you clicked and what settings you had and so on. And that's much more difficult to trace across time. So this is really important for doing reproducible data analysis, which is a really important topic in science in general right now, but that's where code really shines. Also, code opens up a universe of possibilities. If you use a GUI program, you're usually locked into the things that the software developer has coded into their software. But with code, you can do essentially anything you want, which is really cool, really powerful, and really freeing in terms of giving you new possibilities to do things. Okay, great. No questions. Okay. So let's start with some very basic R stuff here. And a lot of times people start with R. You can use R like a basic calculator. And this is maybe a little overkill to use R as just a basic calculator, but it's something you can certainly do. So let me get some of this. I'm going to just be typing some basic code here. Let me clear this up. Okay, great. So if we want to use R as a calculator, let's type some code up here in the editor, like I talked about. That's a good thing to do. We can type something like 1 + 1. Okay, very simple thing here. If we want to execute this statement here that we typed in the editor down in the console, we can come up here and push the run button. It will execute the line of code that our cursor is on. Okay, so very easy to do. There's also a keyboard shortcut that I use all the time. If you're on Windows, it's Control-Enter, I believe. If you're on Windows or on a Mac, it's Command-Enter. So if you put your cursor, you can use the arrow keys. If you put your cursor on the line of code and push control or command return, it will execute that. So I want you to look down here. I'm going to execute this code, and you can see that it executes that statement inside of the console. Okay, you could also type that down here, 1 + 1, and do the same thing. And you can do all kinds of math. You know, this isn't too exciting, but you can do multiplication, division, all these kinds of things that you would be used to. Okay, so just a very basic way of writing code up here and executing it. Okay, let's move on to something slightly more interesting. And before we talk about that, I want to talk about this idea of R syntax. Syntax is essentially the rules that define how you write correct R code. So essentially how you write all the characters and symbols and numbers to make R code that's valid and that can be executed. Okay. Computers, as you probably know, are very, very picky. If you make even the smallest deviation from these syntax rules, you're going to get an error. Those are syntax errors. And as a beginner working with R, you're going to get these syntax errors all the time, and it's going to be very frustrating. Sometimes the error messages that come back are useful. Sometimes they're completely cryptic and you have no idea what they mean. But we've all been through this learning R. So I'd say just hang in there. This is just part of the learning curve, getting through these syntax errors as you get more comfortable with R code. Even R experts make syntax errors all the time. The difference is as you get more experience, you'll be able to recognize these syntax errors more quickly and you'll be able to fix them. So again, please just hang in there. It's part of the learning process. Don't feel bad. You'll get over that hump once you get more familiarity with R. Let's move on to some first steps, some important things. And the first idea we're going to talk about is this notion of variable assignment. Variables are a very important part of coding. And let me motivate that with an example. Imagine you're analyzing some mass spec data and you want to say, filter your data to peaks that have an intensity above 1,000 units, for example. You could write your code and you could hard code, as we say, that number 1,000 in there to do your data analysis with. But it actually makes more sense to take that value and assign that to a variable. A variable is just essentially a little piece, a name, if you will, that you can assign values to. And so in this case, we're making a new variable called myvar. And we use this weird assignment operator. It's the less than sign followed by the minus sign. You have to type both of those characters. There's no space. And then you type the thing you want to assign to it. So visually, it looks like we're taking this, for example, this number 10 and assigning it to myvar. Anywhere you type myvar in your code now, it will refer to this number 10. So if you used, and going back to my example of this intensity threshold, instead of, if you wanted to change that to something else, like, I don't know, maybe 2,000 or 10,000, if you wrote that number explicitly, you'd have to go and find every instance where you wrote that number and change it. And you might miss some places or you might make a mistake. And it makes a lot more sense to assign that to a variable one time, and then you can change that value in one place and make sure it properly reflects in your code. Okay, so variables are just a key piece of coding. There are some naming rules here. These sound a little strange. They can only contain letters, numbers, underscores, or periods. Don't put spaces in there. That won't work. It must start with a letter or a period, but it can't start with an underscore. And it can't start with a number or a period followed by a number. These seem like lots of really specific rules. In practice, most of the time, your variables are going to start with letters. And so if you do that, your variable should work. Don't put any spaces in there, but use letters to name your variables in a descriptive way, and you'll be good to go. Here are some examples of valid variable names and invalid variable names. Maybe after this workshop, you can come back to the slide and try to figure out why these variable names don't work. Okay, so let me give you a quick live demo here. Let's go back to our RStudio Cloud instance here. Let's make a variable here. Let's call myvar, like we had in the example. We're going to type this assignment operator. It's the less than sign and the minus sign, and then we're going to put a value there. Okay. Let's execute this. If we look down here now, if we come back in the console and type myvar, it prints out the value. R is a little strange in what it prints out. Notice there's this bracket, 1 bracket. That just tells us that this is the first item of the thing we returned. So just kind of ignore this for now. Don't worry about it. Don't worry about that. The thing that myvar contains is this number 10. Okay. And now that we have myvar, we can actually refer to it in our code. We can say myvar plus 10, and we'd expect that to give us back 20. And that's what happened. And we can, do any kind of mathematical operations on myvar. We can even have myvar to itself, myvar plus myvar. That should give us 20 as well. Okay. So basic ideas, but it's a very powerful concept of storing values and variables and then reusing those consistently in your code. Okay, now we're going to build upon this idea of variables and storing single values into something a little more complex. We're going to talk about this notion of data structures. And the idea behind data structures is essentially they're like bags, if you will, that hold data. Essentially, these bags allow you to hold data in different circumstances. So just like you'd use, say, a backpack on your way to school, or you might use a suitcase if you're going on a trip, you use those different bags for different circumstances. There are different kind of data structure bags that you would use in different circumstances as well. R has a variety of these different data structures. We're going to talk about two main ones today. We're going to talk about vectors and data frames. This represents essentially tabular data. We're going to talk about those in a later session here, and we're going to start talking about vectors now and why they're important and useful. So one thing with vectors is that they hold essentially data of the same type. If you want to collect a bunch of values together in a single object because they go together, vectors is the way to do that. The thing in a particular vector, if you're storing numbers in a vector, you can't also stick, say, a word or a character inside that vector. They all have to be the same type. So if you have numbers in there, you have to stick with numbers. If you have letters or characters, you have to stick with those inside of vectors. So in mass spectrometry, where might we use vectors? Well, it makes sense for a mass spectrum. We might have a vector that stores M over Z values, another vector that stores the corresponding intensities. So we could have two vectors that define a mass spectrum. And in this case, the two things would be paired up. So this would be the intensity value for this M over Z value. So this is sort of a natural case where we would use vectors. How do we create vectors in R? It's actually not too complex. You'll probably recognize the left-hand side of this expression here. We're assigning a vector to this variable called myvec. But let's talk about how we actually make a vector here. We're going to use this C function here. I'm going to talk a little bit about functions in a minute here, but the C function stands for combine, and we write that C followed by parentheses, and then we're going to list the elements that we want to combine into that vector. Okay, and we separate those with commas, and we can get out a vector here by using this very simple formula. So let me show you what that looks like. Oops, in RStudio. Let's make something called myvec, and we can use the C function. We use parentheses, and then we put the things we want to put inside in there. 1, 2, 3, 4, 5. We can execute this line of code, and then if we print out the vector just by typing it and pushing return, we can see this vector. It has the elements 1, 2, 3, 4, 5. What's cool is that we can actually do math on vectors as well. So let's add 10 to this vector. What do you think will happen if we add 10 to this vector? Let's execute it. What it did was it added 10 to each element of the vector. So that's really useful. We actually did a bunch of math. We actually did 5 math operations here in one line of code. And that's a really powerful thing about R. R takes advantage of these vectorized operations to do lots of code in a sort of a quick and concise way. You can also operate vectors on themselves, myvec plus myvec. What do you think this is going to do? Let's execute it. What it actually did was it element by element, pairwise element, it added the first element of both vectors together. So the 1 and 1 got added together to give us 2. The 2 and 2 got added together to give us 4, and so on. So we're able to do these operations on vectors, which is very powerful. Okay, So
there's a couple of questions.
Yes, great. Let's take a look at the questions. Would you say that vectors hold rows? Oh, sorry. If I click answer live, I don't know, Olga, do people see the question if I click that button?
I'm not sure. It's good to read it out.
Yeah, I'll
actually,
read it
people
out.
on YouTube will not see it for sure. So it's good
of
to read
course,
it
that
out.
makes sense. Okay. Okay, so this question, would you say that vectors hold rows of info? Yes, exactly. You could think of them as holding rows of info. We're actually going to make that more formal when we talk about data frames and data tables. But yes, you can think of that as holding rows of info. That's one way to think about it. Okay. All right, so we talked about performing math with vectors. I showed you that live. So here's just some example code. If you want to go practice this later on, you can come and essentially copy and paste this code into your R session, and you can see what the results come out as. And I have the code here and the expected output here about how you can work with vectors and do these operations. Okay, let me do a poll here because I'm curious. Let me relaunch this poll here. How are we doing? Is this going okay? Am I losing people? Still feeling okay? A little too slow. Okay, I bet there are some some people here that are probably more advanced. Let's see, we have about 80% are saying it's just right. About 10% are saying it's too slow, and there's a couple that are too fast. Again, I think for the too slow and too fast, feel free to go and talk to your TAs, and you can maybe start asking some questions. So thank you for that. Let me get rid of that. Okay. All right, so we talked about vectors. I talked about the C function there, that we use that to make vectors here. But there are other functions that can allow us to operate on our inputs and do some interesting things. And these are called functions, okay? You can write your own functions, but we're gonna be using our functions that are already defined for us. And they're fairly simple. Every function has a name, followed by parentheses, and then the inputs to the function go there. These inputs are the things that the function is going to operate on. And some functions have 0 inputs. So you would just do an open and close parentheses and you wouldn't put anything inside. Others take 1 input. So you put 1 value in there. Some take lots of inputs, and then some take 10 or 20 inputs, depending upon how complex the function is. But essentially, these functions are really important. There's a ton in R. You'll learn more as you work more with R. But let me highlight some of the important ones for working with vectors. For example, if you wanted to find the length of the vector, the number of elements, you could use this length function. Actually, let me just come on over to RStudio Cloud here and do some of these live. So let's get the length of my vec. We can type length. So this is a function. So we have to use the parentheses, and we can put my vec in there. Look down here in the console when I execute this so you can see. In fact, let me clear this out. Let's execute this line of code. And it says that the vector has 5 elements. And that's what we expect, right? There are 5 elements here. We can also get the minimum value of the vector by typing min of my vec. And that should be 1, right? We expect that to be 1, which it is. We can get the mean of the vector. That's a little more complex. That's kind of nice. And we can execute that. The mean of that is 3, as we expect. The standard deviation of that would be my vec. We can do that, run that. And again, these are all functions that R has defined. You can't make your own name without defining something. Like I can't say Ryan Funk and type my vec. This will give us an error because I have not defined Ryan Funk. It could not find this function. These are functions that are defined in R, in sort of base R. So they're there for you to work with. If we want to get the median of the vector, what do you think that function might be called? Obviously, you can't answer me right now because you can't speak, but that function is called median. If you type median my vec, you will get the median of that vector, which is 3. Okay. So other things, you can sort elements. Unique, if you type unique, it will tell you the number of unique elements in the vector. So there's all kinds of these functions. You'll stumble across them as you learn more and more. Looks like we have a question. What's the max? Okay, sorry. So here's another question that came up. What's the maximum number of functions you'd recommend we combine into one line of code? When should we start separating them into different lines of code? Let me give you an example of that. Oftentimes you call a single function from a single line, like I did here. usually you want to do discrete, kind of like sentences. You want to have discrete thoughts. You want to do the same thing here with lines of code. So I would say typically one function goes on one line, but let's do something like this. We can combine functions. Let's say we wanted to get the length of the unique values of my vec. I've combined two functions here. I have the unique values here, and that becomes input of the length function. So we have two functions here, and then we can execute that, and that will give us the length of this. Another option would be we could have, say, unique vec. We could have assigned that to a variable like this, and then we could have executed that. Then we could have used the length function on unique vec like that to accomplish the same thing. So these are two ways to do the same thing. It depends about you. If this is more readable for you, definitely do this. Use more lines of code to make things more readable when possible. Okay, so that was a question about using how many lines of code should you use for these functions. Okay, I'm just looking at the time here. I'd like to speed up a little bit. I talked about working with vectors here, and you can copy this code in for your own practice. Two more concepts I want to cover before we go into our first set of exercises here. The first is conditional expressions. This is a really important concept. It allows you to ask questions about your data, sort of yes/no questions. So for example, you can ask the idea, is my data less than a certain value or less than or equal to a certain value? I'll show you examples so this makes sense. Is it greater than or equal? Is a value equal to something that we want to test? The important thing here is that if we want to use this equals operator, we have to use two equal signs, not a single equal signs. Those are different. So remember, if you're doing conditional expressions, you want to use two equal signs. If we have not equals, you use this exclamation point followed by an equal sign. And these conditional expressions will give back a true or false depending upon the value of the test. So let's take a look at what that means here in some code here. I've assigned a value here to a variable and also a vector like we've been doing. We can ask the question, is my val greater than 100? Well, my value is 123. So yes, my val is greater than 100, and that gives us back a true answer. We can ask if it's equal to 122. We use the double equal sign. That's false. This is not, 122 is not equal to 123, so that gives us back false. We can also do this on vectors. Okay, if we say my vec greater than 20, it will ask this question of each value in our vector. Is 20 bigger than 30? Yes, so it gives us a true. Is 20 bigger than 40? Yes, so it gives us a true. Is it greater than 10? Nope, so it gives us a false, and so on. And you can save these conditional expressions into a vector if you want as well, just by using the assignment operator that we learned about. So where is that useful? It's useful in this idea of subsetting vectors. And this is a very common data analysis need. We have data and we want to either get specific values or exclude specific values. Like I said, maybe we have some peaks that we want to filter out that have intensities that are greater than 1,000. We would want to subset our data so that we could only get the data points that are greater than 1,000 and exclude those that aren't. To do this subsetting, we use these square brackets called the subset brackets. But these are not parentheses like we use for functions. These are square brackets that we're going to use to subset a vector. And there are two main ways I'm going to talk about how we can subset. We can use integer numbers, 1, 2, 3, 4, to give us a position in the vector. Or we can use these conditional expressions that I just talked about that will only keep the elements where that conditional expression evaluates to true. Really quickly, if anybody knows any other programming languages, this is for you. R starts counting things at 1. Okay, that if you don't know about coding, that sounds like a really stupid thing to say, that we start counting at 1. But actually, lots of other programming languages start counting at 0. Okay, so in R, if you want to get the first element, you use 1. Okay, you don't use 0, you use 1. So let's look at some examples of subsetting vectors. So again, we have this my vector here with 5 elements here. If we want to get the first element of the vector, we use the square brackets, and we use the number 1, and that will give us back 30. If we want to get the 5th element, we just use 5 in there instead of 1. There's no reason we can't also supply another vector in here of positions. This will get the 1st, 3rd, and 5th elements of this vector. Okay. Let's use these conditional expressions for something that's actually pretty powerful. We can ask the question, is my vector greater than 20? That will perform this test on each element of the vector. Okay, we can take that entire expression that results in these trues and falses and put them inside of this subset operator, this entire thing, including this variable name used again. And what that will do is only give us the elements that are greater than 20. Okay, so that's actually a pretty powerful thing. You could filter data out by Q values, for example, below a certain threshold. You can use these subsetting operations in lots of different ways. Okay, so here's a little recap here. Given the time, I want to get into our first sessions here. So we're going to transfer it over to our TAs, but let me give you some guidance here. I want you to bring up RStudio Cloud. Let me come back to the workshop here. Come back to the workshop page, and I want you to click on the day 1 introduction to R. It's going to take 10 seconds, maybe 20 seconds for the project to get started up. So just be patient for a second as it boots up this workspace. And what we're going to do is we're going to open up an R file that has exercises that covers the concepts we just talked about. And as you work through these exercises, I recommend if you have the slide deck in front of you, go ahead and go back to some of these sections where I have some code, and you can try copying and pasting some of these things to help you work with your code here. Okay, it's resuming. Great, we're here. So here's what I'd like you to do. In the file browser, I'd like you to click on the day 1 module 2 first step exercises here. I have a bunch of questions here. See these pound signs here? This is a comment in R, and it allows you to essentially write text and notes that won't get evaluated by R. And this is a way you can just put your own notes in your own code here. Inside of the comments, I put a bunch of questions here. So 1.1, I want you to create a variable with this name and assign the value of 60 to it. So I want you to come here and write the R code to do that. And go ahead and execute that here using the run function, and make sure that you get the results down here and you don't get errors. Okay. All right, so everybody, let's transition over to our TA sections, and we're going to give you about 15 minutes to work on this. So let's come back at about, let's give about 10 minutes, just giving the timing to get through this, and you can work on this code later as well. So let's come back about, what time is it, Olga?
It is 1:04 Eastern.
Yeah, so
we can come back at 1:15 Eastern.
1:15, yeah.
Yes. And so for everyone, so now it's the time to sign off and go to your teaching assistants. And from that point, you can just monitor this discussion through YouTube if you would like, and just stay with the teaching assistants, especially if it was going too fast or too slow. If it is going too slow, you can just go and continue other exercises. If it is too fast, well, work out what needs to be worked out. You can also stay here. Nothing will happen here for the next 10 minutes. However, if you'd rather work on your own and just ask questions from Ryan via Q&A, that's an option as well.
Yeah, feel free to ask me of Q&A. Yeah, great. Thank you. So we'll see you back in about 10 minutes. Mm-hmm. Thank you. Which packages that you use to read the thermo raw file? Okay, so I think, let me make sure that we're talking about the same thing. Let me share my screen. Shijun, are you talking specifically about thermo raw files? Maybe you can follow up with your question. Maybe ask another question. Yes, okay, specifically thermo raw files. Okay, generally speaking, I'm going to talk a little bit about this in the next section. You can't read the raw mass spec files into R, but I think I recently saw, was it a paper? And I don't know, Olga, if you know, but I know there might be an R file reader for reading raw files directly into R. Are you
There are
familiar with
definitely
this?
tools for that. So, you
Yeah.
know, the basic R structures are more like array shaped, right? And so the raw files, they are not array shaped, right? So they're
Yes.
more like binary files, right? And XML and so on. So
Yeah.
essentially, someone needs to write a custom function which can access the API of the raw files
Yeah.
and, you know, parse that and somehow make it available in a form which is compatible with R. This has been done quite a bit. So I think if you would like to know more about this, hold this question until tomorrow. So Kylie has a lot of experience with that. And in fact, you can even reach out to Kylie in advance and ask her to talk about this specifically. So that's not her topic. She was going to talk about data visualization, but she knows quite a bit about that. Well, specifically in the context of imaging mass spectrometry, so in fact, Kylie wrote software to read raw data into R for imaging. So she may be less familiar for proteomics or metabolomics applications, but she can direct you to resources for that. But there are problems with that because these typically are large files, they are binary files. So this is not the original intention for R. And well, here you go, MSN base package for sure does quite a bit of work with that, yes, as someone points, yes. So Miguel says the MSN base package is suited to process mass spec data, but it does need to be transformed from raw to MZML format. Yes,
exactly. So that's a common point. And Proteo Wizard is a common program that can actually take pretty much all the major vendor formats and convert them to MZML. So that is one option to do it. As Olga mentioned, these are often binary proprietary formats. And so you have to work with sort of the underlying API. So there are some challenges to that. But I think the mass spec vendors are actually starting to write their own functions to do this, which is pretty cool. And hopefully we can see more of that soon. So.
Yeah, so you know, I think the most standard workflows currently would use other tools used in other languages typically to handle raw files. So besides the format, it's also the size, right?
Yes, exactly.
And so most standard applications now would process raw data elsewhere, export the data in something that looks like a table one way or another. And then, so by that point, the data already more condensed and it looks much more R readable. And then you can work, and then the advantage of R is and that you can interact with this data very easily, make plots, subset, like things that Ryan talked about. However, there is indeed effort to read raw data directly in R, and sometimes it is valuable. And I would say that among other things, it is valuable for people who want to prototype new methods. And R has a lot of functionalities which you can essentially leverage for the prototyping. And so, or you may want to have other reasons to interact with raw data directly. So MSN Base indeed is one such solution. Kylie's Cardinal is another example in R that interacts with raw data. But I would argue that this is more common among developers rather than among users. And so if you come more from the user's perspective, I would say work with some other tools which parse raw data, and R will be at its best when the data is smaller and tabular. So hopefully we can start in 1 minute. So I expect many people will just stay in their TA groups, so we don't need to wait for everyone. We can just go ahead and start.
Okay, great.
Oh, there's one more question.
Another question. Yeah,
no more question.
Well, thank you. Oh, I like those. Those are nice questions too. Thank you.
Okay, I think we can just go ahead.
Great. Yep. Okay, great. So welcome back, everybody. Okay, we're going to, let's see here. Module 5. Sorry, let me back up here. I was going through some things. Okay, so we talked about some basic R code. We talked about things we can do with vectors, we can do with variables, how we can operate on those data structures. Most of the time, though, you're not actually going to be wanting to type data into R. Okay, you're actually going to want to get your data from some other source. And now we're going to talk about how we can get data from data files into R so you can start working with that. I'm going to try to go through this a little bit quickly in the interest in time. We can certainly, you'll work on this in the exercises, and this is hopefully a fairly straightforward topic we can go through. First, and this sort of relates to some discussion that we were having in the main room about what R can work with. R can actually handle a large variety of file formats. In particular, R works the best for formatted text files, tabular kinds of data. So for example, CSV files, but it can be used in other cases. So most open standards, if they're popular and widely used, R probably has a file reader for those. So web formats, JSON, various markup formats, R has functions to deal with those, to read those files. If they're a popular open source or binary file, there's often ways to do that. For mass spec data, you can read in MZML files. In the bioconductor packages, mass spec packages, there are several in there that can read data that has been converted to MZML. In general, you can't, we just talked about this. In general, you can't necessarily read proprietary MS data formats into R without a lot of effort, but that's changing. But as Olga pointed out, really R shines when we're working with more of these tabular types of data. Okay, we're going to use reader functions in order to read this data, and we're going to see some of those examples in here. We're going to focus mainly on CSV files because that's where R really shines. Okay, so like I said, to read data into R, you have to use these reader functions, and there are several built-in reader functions right out of the box with R, and they're pretty reasonably named. Read.csv, for example, reads comma-separated files. There are some other ones here to read, say, tab files or fixed width files. We're going to use a slightly different version of these from the tidyverse package. Don't worry about this right now, but they're just sort of alternatives, reader functions here. And we're going to use similarly named files, read_CSV, read_TSV, and so on. We're going to focus on this one, read CSV. So let's look at what this looks like in practice. To use this read_CSV file, we need to load an external package that provides this new function to us. This is the tidyverse package. It actually contains this additional package called reader that has this function here. So we have to load that library first before we can use that function. Then we can read a file just by saying read_CSV and give the name of that CSV file. If you're using RStudio projects, and example.csv file is inside of your project, you can just write out the name of the file and it will load it up in R with no problem. If you have a bit of a more of a complex directory structure, this is a picture of one here. Imagine we have your project directory here, and inside of that you have a folder called data, and you put the data file inside of there. You have to give this relative path to access this data. So read CSV, you have to give this data followed by a / followed by the name of the CSV file. That will allow you to read the file. If you were just to put example CSV without the /data, R would not be able to find it and it would give you an error, okay? And just first a couple things to keep in mind with CSV files. The first row of a CSV file should, and I actually say must, be the header row. This header row gives the names of all the columns in your CSV file. A lot of times you'll find CSV files that don't have a header. I don't like those files. I think the first row should always be the header with the names of the columns of the data table. These header row names they can contain spaces, but it's better if they don't, at least for working with R. I think a lot of real world data will, but if you're making your own data tables, this first row shouldn't have spaces in it. Two other important things. Every other row in the CSV file, besides the first one, the first header row, is going to contain your data. The number of values in that that are in that row, which are separated by commas, should be exactly the same as the number of rows, number of values in your header, and every line should have the same number of values. You'll often encounter data files that have differing numbers of rows and values, and R will have a hard time reading that kind of file, and those can be kind of painful to diagnose sometimes, particularly if you have some weird error on line 1,236, where for whatever reason, one less value was entered instead of the expected amount. Okay, so that's what a well-structured CSV file looks like.
And there's just one logistics question.
Yeah,
whether the answers to the exercises will be posted.
They will be posted. So I wanted everybody to work through those. give their best shot effort and let the TAs help you. But I'm going to post those on our GitHub site later today. So after this workshop is over, you can go and look at my answers to the exercises if you didn't get through all of them. Be a great way to practice. Just a few ending notes here. When you use the read CSV function, you typically almost always want to write that to a variable. Otherwise, it will just print all the data to the screen, and that's not very useful. So you're going to want to assign it to a variable that you can work with. This output of what this function gives us is a data frame. We're going to be talking about that next. Just a few other notes. R works okay for data files that are, say, hundreds of megabytes to low gigabytes in size. It depends on how much RAM on your computer, but generally R can deal with those pretty well. If you get into like tens of gigabytes, R is going to really start to struggle to work with these data files. So sort of keep that in mind when you're trying to read data into R. Okay, so that wraps us up here. Let me go to RStudio Cloud here to have an example here. I'm going to go back to my Scratch project just to show you what this looks like in practice. I went through that a little bit quickly just in the interest of time, but hopefully that made sense. Let me clear this out. Okay, this is my RStudio project. It doesn't look exactly like yours. Actually, you can see my solutions here to the exercise. You will get those. I'll add those up here. But let's say we wanted to read a data file here. It is in a subdirectory of our project. And let's read this annotations file here. Okay, so what I'm going to do here is, first of all, I need to load. This is just loading the tidyverse package. So we have access to that read CSV file. Go ahead and run that. You're going to see some output here. Don't worry about what this says. Conflicts, that sounds like a bad thing. Don't worry about it. It's okay. I don't need to worry about that. But let's read this annotations file. And again, it's in a subdirectory of our project. So we can type in here dat equals our assignment operator read underscore CSV. You'll notice that RStudio is helpful here. It actually will start to suggest function names here. And it actually, at this point, if you push the tab key, it will complete for you. Okay, so that's really useful. Using the tab key to autocomplete. Let's see that again. I'm typing read underscore CS. You can see that, push tab, it will autocomplete. Okay, so you don't have to type everything out and you get the right name. We need to give the path to the CSV file. It's not in our main directory, so we have to give the relative path. So we need to start with I, P, R. If you type tab at this point, it will suggest auto completions for you, and you can use your arrow key to come down and hit return. It will auto complete that for you, which is pretty cool. Again, push tab, and we can find that annotations file in here and push return. And we can execute this here. And we can take a look at what that looks like. This is what the tabular data frame table looks like. We're going to talk about more of that in the next section, but this is the way to read data into R, particularly CSV tables. Okay, so that was a little quick, but I think we're kind of caught up in here. I think I was hoping about 1:20 here for our first break, and that's, I think, where we're at here. Let's see, does anybody have any questions I can answer? Obviously, if you're with your TAs, they can answer those for you, but feel free to come back into the main room. We're going to take a 10-minute break right now. If you need to use the restroom or get another cup of coffee. So let's come back.
Ryan, just one thing before you would do this.
Oh, please.
I would like to have another poll, because I also had a message that some people didn't get through all the exercises.
Yes.
So I am launching a poll here. Could you please give us some feedback? So your time with the TA in the previous segment,
Great.
Was it too short, just right, or too much? It will give us a little bit of a sense of how much time was needed.
A little too short. Okay. Yeah, so TA time is really important. Looks like it's sort of 2/3 are a little too short. I apologize for that. I'm trying to cover a lot of material.
No,
here.
but I think it's fine. So let's take, how much time do we need? Let's take what you were saying, Ryan, 15 minutes?
let's take 10 minutes if you don't mind. Maybe
10
come
minutes.
back
Okay.
at 1:35 if you don't mind.
Okay, so let's take 10 minutes and please talk to your TAs about whatever questions were unanswered, and we will kind of try to space it out a little bit. So another thing is that you can talk to your TAs a little bit longer if needed, and if you can also work on the exercises that we have today ahead of tomorrow, this will set you up for tomorrow's lecture as well. Okay, so let's take 10 minutes. So we're back at 1:35 Eastern.
Great, thank you. In addition to hopefully getting into a little more interesting things, we're going to start working with data tables, in particular data frames here. And this will sort of lead into the last section. We're going to talk about doing some cool data manipulation using this dplyr R package.
Do you mind if we just have one more poll, just kind of after the break, yes, to see? So just the presentation speed, just to kind of get a sense.
Okay, let me relaunch the poll. Continue. Okay. A little too fast, sorry.
So if it is a bit too fast, just take it slower with the teaching assistants on your own time. So don't worry if you don't catch up with everything. You have the slides still, you can come back to that. By the way, the presentation is recorded, so you can watch the videos later. So it may be a good use of your time just to spend a little bit more time with the TAs, maybe at a different pace.
Yeah.
And get back to the video and to the slides whenever you're ready.
Yep. Yes, exactly. And also, it's nice this workshop takes place over 2 weekends. So if you have questions, you can also follow up tomorrow and the other days as well. So we want to make sure that we can answer your questions. Okay, so getting back to the topic at hand here, working with data tables. What we want to cover here is understand what a data frame is, how we can work with them, and do some basic operations on the data frames. In particular, we'll talk about subsetting as well. That's all a key operation that we work with data analysis. Why do we care about data tables? Data tables are everywhere. Tabular data is everywhere. If you've ever worked in Excel, its very interface is arranged in a table. So its interface is designed to work with tabular data. We saw that CSV files represent tabular data. We often utilize tables to communicate information. So we might make tables in publications that we write or send tables to other people. So short of it, tables are really important part of data analysis. I probably don't need to go into this in too much detail, but tables obviously have rows and columns. The rows and columns have structure. They are arranged in that way for a very particular reason. Columns typically relate data in some way, as do rows. If you were to take a data table and mix all the values up randomly, that wouldn't make any sense. It's the structure of the table with the rows and the columns and how the data is arranged that actually adds meaning to the data. Okay, so when we think about tables, data frames, this is what I mean, this tabular data that's arranged in rows and columns. How does R deal with storing tabular data? Tables like this? Well, it uses a data structure known as a data frame, and very specifically in R code, you would write data.frame. This is one of the most important data structures in R. It's frankly the data structure that I'm working with most on a daily basis in my job. I'm working with data frames all the time. We saw the read functions in the previous module to read data files in, like CSV files. These functions give us a data frame. So when we assign the output of a read function to a variable, that is data frame. And so data frames are everywhere. It's just something that is really important. You need to learn to work, that everybody with R needs to learn to work with. Slight little nomenclature thing I have to point out. We're using functions from this tidyverse package. I'll talk a little bit about that later. But the tidyverse set of packages has made an updated data frame that makes the printing look a little nicer and has some additional features to it. Those data frames are called tibbles. Weird name, I know. Maybe kind of think of it like a table, but with an I instead of an A or something. I don't know. But anyways, tibble. But I just want to say that when I use the term data frame here, I'm generally referring to either a data.frame or a tibble. Essentially, I'm referring to a tabular piece of data. Okay, so that's what I mean when I say data frame in general. If we print out a tibble to the R terminal, and I'll show this in some examples, but for example, we use the read CSV function, assigned it to a variable, and then printed out that variable. This is what the output might look like. And there's actually a ton of really cool information here that it tells us about that table just by printing it. So first of all, it tells us that the thing is a tibble. Again, that's just a rectangular table of data. Gives us the number of rows here. So this has 1.2 million rows. That's a big data file. Gives us the number of columns. It gives us the first several columns of data. These are the names of those columns. Again, I talked about that header row for CSV files. This is what I mean. These are the header rows for those CSVs, these names here. This line here tells us the type of data that's in the column. This CHR stands for character. Essentially, it just says there are words here. So we have words here. We have words for the peptide sequence. If we look at the precursor charge here, this is a charge state of 3, and that's represented as a number. This is double. Double is kind of a weird name for a double precision number. And so we can see the types of data that's there, and then we get the first several rows of the data. Because this is a really big data table, R does not want to try to print 1 million rows out into the console. That would be a headache. And so it just summarizes what it found in the rest of the data here. So it tells us there's essentially 1.2 more million rows that it's not showing, and 9 additional columns or variables. And those are those names and those data types. Okay, so this is really kind of cool. Just by printing out a tibble, you can get a lot of information about it. And if you are trying to work with data, it's very important that you understand the structure of the data. There could be problems in the data and so on. And this is a nice way to sort of quickly diagnose what's there. We talked about several functions for working with vectors. I think you'll remember we used the length function, for example, to get the number of elements in a vector. There are similar functions that we can use to work on data frames. But remember, a data frame is not a single, say, row or a single vector of values. It has rows and columns. So length you can actually use length on a data frame, but it will do something a little bit different. But in any case, you want to talk more about the number of rows and columns. So you can use this function nRow or nCol and use a data frame as the input, and it will tell you the number of rows and columns if you want to get those in your code. Dim does the same thing. It finds the dimensions, but it gives back the number of rows and columns as a vector to you. The names function gives you back the names of the data frame. It can give you back these names here. I'll show you this cool view function here in just a minute, how you can actually get an interactive view of the data table. And this is particular to RStudio. This works in RStudio. This last one is a little bit weird. This is some weird syntax, but if you give the name of the variable followed by a $, I know it's really weird, $, and then you give a name of a column here, you will get the elements of that column as a vector. And you can operate on that vector just like we described in the previous sections. Okay, so you can use that information you learned to operate on data columns in a data frame by using this $sign operator to get that data. Okay, so let's take a look at this. I have some code here you can copy and paste on your own, but let's go to RStudio Cloud and do some of these things in real time. Okay.
And Ryan, so there's a question.
Yeah.
If you gave some specific files to work with. So there was previously a question.
Okay, I did. Again, if you go to your RStudio Cloud instance and you click on the day 1 introduction to R, those files are located there in the project. Okay, they're here for these data files here in this path here. Okay. Also, sorry, let me just quickly go to the GitHub site. I should have mentioned this as well. But if you're kind of working on your own, not in RStudio Cloud, if you go to the exercises, this is the GitHub link. Can we post that in the chat? Let me do that or maybe the Q&A, or no, the chat, I guess. Oh goodness.
So it's the same GitHub link as you had in the original email from Thursday. So it's
if you go to exercises, you'll find the exercises here, and the data. There's a little bit of work to do, but I talk about this in the README here, how to do this. But also there's the data directory here, and you can download the zip file, unzip it, and you'll get the same files. Okay, so hopefully you're working in RStudio Cloud, and it's just right here for you to work with. Okay. Okay, great. Let me actually come here. Okay, let me close all my windows. Let's go to our, apologies, let's go to my scratch space. Okay, so again, we're working with a data frame here. So we're using the read CSV file. Because this is in a subdirectory here, we have to put the full subdirectory path into the CSV file. We're going to execute that. If we type the variable name here, we get this nice output of the tibble. We're reading a different data file than I showed in the slides, just because this is smaller and easier to work with. But this is the tibble, has 12 rows, 3 columns. We can type n row on the dat, and we get the number of rows, and call dat gives us number of columns. Let's try this. This is kind of the weird syntax. Let's type dat. And one of the names of these columns, let's get the bioreplicate. Bioreplicate. If we hit return, we get a vector now, not a data frame. We get a vector of values that gave us all of these things in the bioreplicate column. Okay, and there's no reason we can't do math on this just like we did before. It doesn't really make sense, but let's say we wanted to add 10 to this value. We could do that, and we could get essentially 10 values out from that. Okay, so we can operate on data frames using this $sign operator to get specific values in the columns. And I have some code here that will talk about that. Oh, here's a good one, unique. If we want to get like the unique conditions in this data frame, notice these conditions are duplicated. If we get the unique of the conditions, it will just give us the 4 unique values of the conditions. Okay, so that's a nice thing. We could combine that with the length function, for example, to get the length of the number of unique values, and that's 4. Okay, so that's an example of working with that. Okay, let's keep going. Recall that we talked about subsetting vectors before, and we used the bracket operators. I don't know if you remember that, but we used the bracket operators, and we could put integers in there to get specific entries in there, or we could use conditional expressions to ask for example, which values are greater than a certain number. We can do data frame subsetting as well. We also use the square brackets operators, but remember, we have a table now. We just don't have a single one-dimensional vector. We have a table. We have rows and columns, so we have 2 dimensions to work with. So we use this subset operator that need to give both a row selection, so a way to select the rows, a comma, and then a way to select the columns. Okay, so essentially it's like doing both dimensions of the data frame here. One common mistake that frankly I make myself and new users will probably make is that if you're going to subset a data frame, sometimes you might forget to put the comma in there. When you do these subset operations, you always need to have a comma in there to separate the row and the column selections. Okay, so let's take a bit more detail about what this looks like. Imagine we have a data frame called mydf. We're going to subset it with these bracket operators, and we're going to define a row and a column selection. The row selection, just like actually row or the column selections, just like the vectors, we can just give a vector of integers. Okay, and that will give us back the, say, the row number or the column number for those things. I'll show you an example of that. Particularly for the row selections, this is a useful way to give a conditional expression that will allow us to keep certain rows where the condition evaluates to true or reject rows that correspond to false. In terms of the column selection, you can do that as well, but that's not quite as useful. Sometimes it's useful to give the names of the columns instead as a vector. I'll show you an example of that. But like, let's say you just want to get, you know, a couple columns in the data frame and you want to refer to them by name, you can use that as well. A couple little tips here. We've talked about making vectors by typing out, using the C function and typing out all of the elements. There's a shortcut to that. You can use this colon operator. So if you wanted the numbers 1 through 5, you can type 1:5, and that will give you the same thing as this C operator. This is used a lot when you subset data frames, to use this colon operator. Another thing here is, if you don't specify a row or a column selection, that's okay. It will give you all of the rows or all of the columns, okay? But the thing is, you just have to make sure that you have the comma in there. If you don't put the comma here, you'll get an error that comes out. So for example, if this code right here is exactly the same as if you just type the data frame by itself, you didn't subset anything, okay? Okay, so let's see. I think I have some examples here. Great. So let's go back to our RStudio Cloud instance, so I can do this live. Okay, so let's look at our table here. Again, it has 12 rows and 13 columns. If we wanted to just get the first row, we can type that. And let's say we want to get all the columns. So we give a row selection of 1. It says give us the first row, but give us all of the columns. We get all the columns if we don't specify anything. So we can do that. We got just the first row. We could get the 12th row by doing that. We could, like we did with vectors, put a vector of integers to get the first, third, and 5th rows. We could also do a column selection here. And let's do a column selection first by number. So let's get the last 2 columns here. So again, this is our row selection. First, we have a comma, and then we have our column selection. We'll get columns 2 and 3. Should give us back condition and bioreplicate. And that's what we got. We could also do it this way. We could say condition, and we could say bioreplicate. This is actually a little more explicit. I think it makes it a little clear about what we're doing, and we get the same kind of table back. Okay, let's see what else I suggest here. Oh, let's do the conditional expression. This is a really useful thing. So let's say, again, let's look at our data table. We have different conditions here. Let's say we only wanted the data for condition 4. Let's do this. Take our data frame. We're going to do a row selection. This is a little complex. You might need to work with this on your own for a little bit and play with this, but we're going to say dat $condition $= condition 4. This will give us true for any time the condition happens to be condition 4, and will give us false where that's not true. And let's get all the columns back. So we have to put a comma. Don't forget that, because you'll have problems. And now we get a table that comes back that only has the data for condition 4. Okay, so that's really useful. Imagine you had a table of results and maybe identification results from a mass spec run, and there is maybe a Q value associated with that. You might want to filter that at a certain threshold, and you could use syntax just like this to say, give me all of the rows of my data table where the Q value, say, is below a certain threshold value. Okay. Looks like we have a question here. Let's see here. So the question here, can the sorted subset be exported as a CSV file? That is a great question. The answer is yes. I'm not going to cover it in detail, but just like there is a read CSV file, there is also a write CSV file. You would give the variable name like that here, and then you would give a file name, myfile.csv. Okay. Maybe we can cover that in more detail, but there's a way.
And maybe you can just show how to use the question mark, how to get documentation.
Oh, that is a great idea. Thank you, Olga. Pro tip here, actually, maybe a beginner tip. For any kind of function, like you don't know how to use the write.csv function, right? I just kind of told you how to do it. If you put the name of a function and put the comma in, or sorry, the question mark in front, watch what happens in RStudio. Look over here. We're going to hit return. Boom, it pops up this help page. Sometimes it takes a little while to load for some reason. And it will give you all of this wonderful documentation about this function. let me be honest, as a beginner, when I looked at this stuff, it was almost a little confusing, but you can use this to kind of understand what the functions are, what the arguments are, and so on. And so you can use this to start to kind of understand how the function is used. Okay, thank you, Olga. That was good. Okay. So again, we have a lot of code here. I encourage you to try this on your own. You're going to try some of this stuff in the exercises to get more and more familiar with working with these data frames. Okay, so some recap here. We're going to now transition into another work session here. And I think we're going to try to leave some extra time here for you to work. Let me get you set up before we go over to the TAs, or if you're with you, or if you're with the TAs already. I would like you to go to your project. And I'd like you to work on the file called, I should probably just keep this up, but work on the file called module, I think it's module 4. We're on module 4, data frames. There are going to be some questions there, just like we did before. You may not get through everything, but again, all the code is there. I'm going to post the solutions so you have those to work with, and hopefully your TAs can help you as well. Here's what this looks like. Again, I just want to give you an intro before you start getting to work on this. First of all, we have to make sure that we load the tidyverse library. So make sure you execute this statement before the rest of the code here. We're going to read this big data file here as a CSV file. I've added an additional argument, additional input to this file. I can describe this later, but this essentially helps the reader function read the file properly. So just take it as some additional syntax for now. Don't worry too much about it, but just make sure you do that. So if we load this tidyverse function, or sorry, load the tidyverse package, then we can execute this statement here that is already inside your file. It's going to read the file for you. It's pretty big. And now you have this data file to work with, so you can do your exercises here. Okay, great. So let's send everybody off to their TAs. Olga, shall we give 20 minutes? Do you think? I think we can still meet our timelines if we give 20 minutes here.
I'm sure, yes.
Yeah, let's do that. So this is a really important section. So let's spend some time here. So let's meet back at, what time is it, Olga?
So it's 1:57, so let's make it 2:18, whatever, right?
Sounds good.
Yeah.
2:18-ish, yeah.
2:18-ish, yes.
Great, okay.
So please join your TAs, but if you have small questions to Ryan, you can also use this time.
Yep, I'll be here to
ask
answer
questions here.
Yeah.
And there are a couple, like one technical question already in the Q&A.
Great, okay, let's take a look. Okay. Interesting. Okay, great. So Minia, I hope I'm saying your name right. And thank you for posting this code. This is great. This makes it really helpful for me to help diagnose these problems. Computers are very finicky. They like things to be exactly stated right. And there was one little minor syntax error that you made here. And let's take a look at that. Data here. Okay, so in condition here, notice the condition has a capital C here. And unfortunately, you used a lowercase c. And yes, computers are that picky. It doesn't like that. And so can you try the code again, but put a capital C there instead of a lowercase c? And how I diagnosed that is that the Tibble output said that there were 0 rows and 3 columns. Essentially, it wasn't able to subset properly. So it gave you back no rows because none of this condition was met. Okay, so give that a go and maybe let us know if you got that, if that fixed your problem. Great, looks like that worked. So yes, coming back to these syntax errors, this is going to drive you nuts. It drives me nuts sometimes as well. It's just part of the thing. And the key there is just to look at things sort of really carefully and try to diagnose things. You'll get more experience. Like this error mess. So the fact that you got 0 rows out kind of led to some evidence that the conditional expression that you wrote wasn't quite correct. So, okay, good. Okay, more questions here. Let me, oh, no, let me make these done. Great. Okay, Shijin, looks like you have a question here. Why are the outputs different? Oh, that's interesting. Okay. So the second one is what you probably intend to do. We want to, and let me bring up RStudio myself here. Okay, so let's take a look at that. So let's see, let me type out your code. So you said distinct dat.
Ryan, you need to share your screen.
Thank you, goodness. Zoom is hard. Okay, here we go. All right, so you said distinct. So this is great. This is a way about sort of deduping things, that file name. Is that what you typed? Did you get an error? I suspect that's what happened, because that's not really how distinct worked. I'm sorry, you're working with the other data file. Is that right, Shijin? I'm going to assume that that's correct. Let me read that data in. But essentially, let me give you the gist of it without going through. Distinct is going to give you distinct elements of this data frame, whereas the unique is based upon the file name, whereas the unique is actually working with a vector here. Okay, so the output of that $ file name, that is a vector. You're going to get the unique values of that vector. And that's essentially a different kind of data structure by using the distinct function with dat in the file name. Okay, so it's sort of working with two different things. Let me read this in so I can actually take a look at some specifics here. I think you're working with this file. Okay, so do distinct dat. Yep, okay, dat2, and then you put file name. Okay, so it's interesting here. Again, it has to do with data structures. When we said distinct dat2, we got actually back a table. This is actually a tibble. Okay, this is not a vector. This is a tibble, because we essentially did a subsetting, if you were, of the data frames. Let's look at this other version of this unique dat $sign file name, or dat2. I'm sorry, dat2 $sign file name. This is a vector. So they are different because they're different data types. Distinct operated on a data frame and gave us a data frame back, which is not the same as a vector. Even if the data frame is only one column long, these things are different. But let's try this alternative here. Distinct dat2 $sign file name. This is a little weird, but we can actually use the $sign nomenclature here, where we're going to index the output here. And you can see that now that we get that vector, it matches up with what we got there. So hopefully that answered your question. It's just a different kind of data type because the function returns something different. Okay, another Q. Got it. Thanks. So and just also a way to think about that's a nice thing to take a look at the outputs as well. The tibble will have this kind of format in here, so you know what the outputs look like. Vectors look like this. They have these little index values on the left side here, so you can tell that that's a vector. You can also say, a little complex, but you can say type of dat $sign dat2 $sign file name. It tells us that this is a character vector. Let me get the distinct version of this. Type. Again, this is more advanced, but it lets us know that the types are different. Also, the class operator kind of does that as well. Lets it know that it's a data frame. All right, there was a question that came down, sort of, my apologies, about I think one of the exercises asked you to view dat. looks like there's not enough memory. I apologize on this particular version of the workspace. So please don't do that so your workspace doesn't crash. We can allocate more memory. This won't be an issue tomorrow and going forward. So please don't do that. I'm going to demo the view function when we come back so you can see what those results are. So just skip that question for now. It should work fine on your own local computer when you have more memory. So just please skip that question for now. Thanks. Okay, I think we're going to be starting here in a couple of minutes. So if people are obviously welcome to stay with the TAs if they would like and watch on YouTube, or come back to the main room.
And let's make another poll to see how
How people are
useful.
doing. Great. Should we do the, what would you like? More time for TAs, or what would you like?
I think more time for TAs. I think that's good.
Okay. More time for hands-on. Oh, that's good. Let's relaunch this poll. Continue. Yeah, that's great. Well, probably only the people in the main rooms will see it, though. Is that?
That's fine. That still gives some information. Well, it's
No,
probably
definitely
a bit biased, right? So those who need more time, they're still with the TAs, right? So right. Yeah, it looks like those who are here are doing fine, but probably half of the participants.
Yeah, it's going to be a mix. So maybe they can stay with TAs. Okay. All right. Okay. So I have a game plan here. I'm going to skip one of the sections entitled Introduction to Tidy Data. That was mostly kind of a for your info section anyway, didn't really deal very specifically with R code. It's in the slides, and I encourage you to go and take a look at that. But just very quickly to summarize, the idea of tidy data is really important to data analysis in general, I would say, and it's really it's a key theme in the R ecosystem in particular. There is a sort of a strict definition of what it means for data to be tidy, but for now you can just think of it as data that's well structured in a well-defined way that allows you to start doing data analysis on it, start working with the data. And that's as opposed to messy data, which might have all kinds of structural deficiencies in it, or the way in which the data is stored. That kind of data is very difficult to work with, and you typically need to massage that data to make it tidy before you can start working with it. And so that section just talked a little bit about what tidy data is. And so the game plan that I'm thinking here is we're going to finish up with this last section. We can go for about 20 minutes here. We're going to be talking about maybe the most advanced piece of the workshop. Makes sense coming at the end, but we're going to talk about doing some really cool things about working with data frames and a package called dplyr that allows us to do some pretty cool data manipulation operations with a relatively small amount of code that actually turns out to be very human readable. So we'll spend about 20 minutes there on that section. We'll give another 20 minutes for the last exercises there. And then that should leave us about 15 minutes to wrap up with some final thoughts and maybe some additional questions if we have time. All right, so let's get back into it. I'm going to share my screen. There was one, I apologize. There was one question on the latest exercise that asked you to use this view function to look at the data. Unfortunately, the data table was too big for this particular instance that I set up for the project, and it sounds like it was causing problems. I just wanted to quickly show you what this view function does, because it's really pretty cool. Let's look at a small table first. So this is not the table you were working with in your exercises. This is a small table. Let's use view with a capital V. That's really important. Lowercase v won't work. View, and then we can put this table here that we're looking at. Hit return. And this is going to happen in RStudio. This is important because this is an RStudio thing. You can see it popped up a new tab here. Okay, our code was over here. It popped up a new tab here. And this is actually a scrollable, sortable table. You can click on the column headers to sort things. And this is just a nice way to look at the data and sort of interrogate it. So that's useful. Let's take a look at the big data file, the big data frame. Unfortunately, that was crashing in the systems. We're only going to look at the first 10 rows. And we know how to do that now, right? We can use indexing, data frame indexing operations to do that. So let's say view, oh, sorry, let's type our dat. Let's get the first 10 rows. So we're going to use this colon notation, 1:10. That will produce a vector of values 1 through 10. And then we're going to put a comma and get all of the columns there. So this gives us just the first 10 rows. Sorry. I read this big data file into DAT2, just so you know. This is the one you've been working with. So let's look at DAT2. It looks like this. There are actually extra columns that we can't see because it's too much data. So if we put the view function around this and hit return, we get this cool table that pops up. And now this is actually really useful. We can scroll through the table. We can see the values. We can sort on different values. So that's interesting. I guess that makes sense. And you can sort on values and those kinds of things. So it's just a useful way to look at data. So view is just a really nice way to take a look at things. Looks like there's a question. Great. Okay, so anonymous attendee asked the question, is there a difference between head DAT 10 and DAT 1 to 10? The answer is no. So we could say head DAT to 10, and that will give us the first 10 rows of that data frame, or we could say DAT to 1:10 with a comma there, and it's all good. And again, if you don't know what the head operation is, you can type $head and hit return, and you will get the help function for that. That will give you more information. Okay, great. Let's go back to the regularly scheduled programming. Okay, we're going to talk about doing data manipulation on data tables using this really awesome dplyr package. When I first learned dplyr, and this is a relatively newer R package, maybe in the last 5 years or so, it really sort of redefined how I think about doing data analysis. It's extremely powerful, extremely deep. We won't be able to get into all the details here, but just note that as an R user, this is like one of those key packages that will really make a big difference in your work. Okay, so the goals of the module here, we want to understand at a basic level, what are fundamental operations we can perform on data tables and that are fundamental to common data manipulation challenges. Then we're going to learn about this dplyr package that I talked about and how it helps you do these common data operations. Related to this, and this will be a cool thing, we're going to talk about this pipe operator. It looks really weird. It's a % greater than %. So it's even weirder than the assignment operator, which was 2 characters. This one is 3. We're going to talk about this pipe operator and how we can use these dplyr functions to make essentially these data pipelines using a relatively small amount of code that's surprisingly human readable. Okay. So very quickly, dplyr is an R package. Okay, this is a contributed package that somebody else wrote. They wrote code, and this package provides us new functions that we can use to work with our data. Okay, just so happens to be part of the tidyverse. I didn't talk much about that. Just note that the tidyverse is a ecosystem of R packages that works with tidy data frames. The kind of data I talked about briefly at the beginning of this section. So let's talk about the main fundamental challenge that dplyr solves is dealing with common data manipulation operations. Okay, and the idea here is that dplyr defines these operations as a set of verbs, if you will. So we're going to perform actions on our data tables. Okay, these verbs are represented as functions. We've been using all kinds of functions throughout the course. The C function to make vectors and the min function, the max function. These are just more functions that are going to do things for us. Unfortunately, there aren't too many of these verbs. We're going to see these in just a second. And so that helps you, hopefully they make them easier to work with and to remember. And really a key thing about dplyr is it helps you focus on the question you're trying to ask rather than the mechanics of how you can go and answer that question. And we'll see in a case where a lot of times the dplyr code almost translates into how you would describe a problem that you're trying to solve. So the code that solved the problem kind of maps to how you might say it in English a little bit. You'll see how that works, but it's a really cool kind of thing. Okay, so let's talk about these fundamental data manipulation operations. So imagine you have a table of data. Let's think about the common ways in which we might manipulate and operate on that table to do things. Okay, and there's really just a small number of sets here that we're going to talk about here, and that actually cover, I would say, maybe a large majority of the cases that you encounter when you work with data. Let's say you want to add a column to your table. There's going to be an operation that will essentially stick on a new column on your table, and typically you want to use this if you have some values in your table and you want to operate on them in order to get some new transform value. You can add a column. We've talked about subsetting both vectors and data frames. There are also dplyr operations that allow us to subset, and there's one version that allows us to pick specific columns. There's another version that allows us to pick specific rows. So these are like our subsetting operators. There's a way to reorder a data table by sorting rows based upon certain values. These last two are really cool and really powerful. It's the idea of grouping subsets of data. Imagine, for example, you've run a study and you've measured the mass spectra data on maybe a cohort of healthy people and a cohort of people that have some kind of disease. And you could have a table that sort of relates to their analyte values that correspond to those two groups. You can use this group subset to say group by the disease status of the patient, by the healthy and the sick people, and then perform statistical summations within those individual groups using the summarize command. So you first group by some column in your data, and then you can compute summaries of those data. And this is really, really powerful and something that I pretty much use every day in my everyday job work, and is just a really, really powerful thing to do. We will see specifics of this in just a minute. In dplyr, like I said, these operations are embodied in different kinds of functions, or these so-called dplyr view verbs. They roughly correspond to kind of what's going on. So mutate adds a new column on. It's like, I guess, mutating a new appendage. Select takes columns. Filters gives you specific rows. Arrange reorders the table. And then we have this group by and summarize, which often come together to sort of do these per group summaries of the data. We're going to see how all these functions work in just a minute. Oh, looks like there was a question. Let's see. Okay, so here's the question. Is it common to perform functions on the groups or subsets of, say, group subject, or is that on the data resultant from a particular operation? Let me describe this a little bit more, and let's see if it sort of makes more sense here going forward. Okay, so I can keep that there for now, and we can come to it. Okay, so these are dplyr verbs are functions. Oh, another question here. What do we got here? How to deal with different population versus. Oh, okay. So a question was about different population sizes. That's another question about statistics and sort of dealing with imbalanced sets. We're not going to talk about that here, unfortunately, but so I'm going to have to leave it at that for now.
Maybe I can add, we will have a very, very short session on statistics, I think on day 3. But you know, this workshop is really about R implementations as opposed to statistical methods and so on. If you're interested in that, I very much encourage you to look into the May Institute. This is a program that we organize every May, like in the month of May. And we hope to do it again online this coming May. But from the previous instances, all the materials are online, and in fact, they're on the same YouTube channel that you are using now for this program. So there's a lot of documentation already on statistical methods. And maybe we can talk about this a little bit on day 3, but a lot more is available from other programs.
Great, great. Yeah. Okay, Raquel, I'm going to dismiss your question if you don't mind, and go ahead and please re-ask it again if we don't quite cover it. Okay, so like I said, dplyr defines these data operation verbs. They are just functions like we've used before. One key thing about these dplyr verbs is that the first input that you give is always a data frame. Should be a tidy data frame specifically, but is a data frame. You'll see how that is important a little bit later when we talk about pipes. But you always use these operations. So like mutate, you give the data frame that you want to operate on. There could almost always there are additional arguments or inputs that you need to provide, but the output of this is going to be a new data frame that simply adds a column to MyDF. And select, we can do select on the data frame that gives you specific columns. One important thing is that these dplyr verbs always give back a data frame, okay? And that's important as well. So you give it a data frame as input, and it returns back a new data frame that has been manipulated in some way. Okay, so that will be important for our pipeline discussion that we'll talk about shortly. Let's talk about some specific of each one of these dplyr verbs and some cases about when you might want to use them. And then I'll show some sort of more real use cases where we'll do them. Take the dplyr mutate function. Typically, you use this when you want to add a new column to your data frame, and usually, not always, but usually, this new column is based upon existing columns in your data. So I have some code here. Again, you can copy and paste this on your own to practice, but we're going to read this annotations data file that we've been looking at. Let's go back to this is this data table here. Whoops, let me do this. And let's say for some crazy reason it makes no sense, but let's say we wanted to add a new column here that takes the bioreplicate value and multiplies it by 10. We'll have more reasonable examples here in the exercises that you can work on. We can use the mutate command. We give that input. This next step is a little bit tricky, but bear with me here. We need to give the name of the new column we want to create. So let's call it biorep times 10, kind of verbose there. So this is a new column we're going to create, and this is its name. It's going to show up in our output. We have to say a single equals sign. This is just syntax for now, a single equal sign, and we have to specify the math that we want to do in order to derive the values that we want to assign to this new column. So let's take, and we can use existing column names in our data frame, which is really cool. So we can say bioreplicate times 10. And what it's going to do is going to take all of these values and multiply them by 10. So let's take a look at that output. Okay, cool. So we got a new table here. It looks just like our old table, except now we have this new column. We've mutated a new column onto it called, and the name is biorep times 10, and it is in fact 10 times these values here. Okay, so that is a very useful kind of thing. And you could probably imagine all kinds of use cases where you would need to do this. I have some discussion of, again, that syntax here that you can review in the slides on your own. Select is really actually pretty simple. Again, this is just selecting specific columns, or essentially getting rid of the ones you don't want. Let's go back to our table. So let's take our dat data frame here. Actually, I'll type here. We can say select dat. And what we're going to do is we're actually going to give column names now. So you specify the columns in a vector using the C function that we learned about. And let's put run and bioreplicate. Okay, this is going to give us back a new table that just has those two columns there. And in fact, if you reorder these, we'll put bioreplicate first and then run. Whoops. It will actually reorder that as well. So even though run was first in the original table, we could actually sort of reorder the things depending upon the order that we specify things here. And just remember, we know this as well. We could also have done this indexing by using our indexing notation where we put bioreplicate and run, and that gives us the same thing out. So these two versions of the code do the same kinds of things, just another way to do it. I'll show you why this tidyverse way to do things is actually really cool when we talk about pipelines. Filtering is really extremely powerful, and it leverages those conditional expressions that we talked about. And in particular, we're going to write conditional expressions like the following. Let's again take a look at our data frame. Imagine we only wanted data where the condition was equal to condition 4. We did this, a form of this previously, but now we're going to use these tidyverse, these dplyr verbs to do it. We're going to do filter dat and then write a conditional expression. We're going to refer to the columns that already exist in that table. So we're going to say condition equals condition 4, and that will give us just the table filtered to just to those rows where we have condition 4. Okay. Arrange. Arrange is just very simple. You give a column name and it will just sort the rows based upon the values in that column. So if they're character vectors, it will do an alphabetical sort. If they're numeric vectors, it will do a numeric sort. So that's really straightforward, just rearranging the data. Just as a little tip here, if you want to reverse sort, you use this DESC. This is a descending function, and you can just use DESC around the column that you want to sort on, and it will reverse the sorting. This next one's really pretty cool and powerful. This is the group by plus summarize operation. Let me show you what the idea here is that we're going to group our data by a certain variable in our data. And probably actually, I think just easier to show you here. So in our annotations table, we have 4 conditions. Let's say we wanted to compute, and again, this is a little bit of a trivial case, but let's say we wanted to compute, for some reason, the mean bioreplicate values for each condition. We can do that by using this group by and summarize values. So first we can get the grouped data where we say group by dat, and we can group by condition. This is interesting. It actually didn't do anything with the table explicitly. It actually will print out the table as well. But notice it says that we now have 4 groups in here and we're grouping by condition. So behind the scenes, R is now thinking this as 4 separate groups, not as one individual table. And now if we do summarize on this group data, we're going to, this is a little bit like a mutate command, but not quite. We're going to give a column name. Let's call this mean biorep, and that's going to equal mean of the bioreplicate value. And again, this is a little contrived because these values are actually just all the same by condition. But let's look at that output here. We got 4 rows here because we had 4 groups, and we calculated a statistical summary, the average of these 3 values for each of the bioreplicates. And so we were able to do that there. So that's really cool. Imagine you had a proteomics data set and you wanted to calculate the average or maybe the summed intensity for all the peptides in a given protein. You could group by the protein column, and then you could take the average or the sum of the peptide intensities that are associated with that protein. Okay, so that's a use case example where this would come by. This is more complex. I admit that probably everything may not make complete sense right now, but just note that it's really a cool and important thing and worth spending time in to learn and learn well. Okay, so I was hoping to be done by now, but I want to talk about these pipelines. So just give me maybe 5 more minutes before we go into exercises. These dplyr verbs really shine when we can combine all of these data operations together in a data operation pipeline. Let me talk about what I mean about that. And in order to do that, we need to talk about a new operator called the pipe operator. Again, this is 3 characters. It's a % sign, a greater than sign, % sign. And then yes, you have to type that out. There's actually a keyboard shortcut in RStudio that you can use to have it put that in there for you. But in any case, this is a pipe operator. It's designed to look like this for a reason. It's supposed to look like an arrow that's taking something from the left side and then piping it, if you will, into the right side. Okay, so think of a pipeline, and that's showing you the direction of the pipeline. And so the idea here is that given an input data frame, we can pipe that into one of these dplyr verbs to produce some modified data frame. Okay, so we talked about using these functions directly. Now we're going to talk about this pipe operator to use these dplyr functions. So just think about this as a template. We have our tidy data frame, and we pipe that data frame into a verb. It's going to produce some modified version of that. So if we pipe a data frame into mutate, we're going to get a data frame with a new column. If we pipe a data frame into select, we're going to get a new data frame with selected columns. If we pipe a data frame into filter, we're going to get a data frame where the rows have been filtered based upon all of these operations. Okay, now we need to take the next little piece about understanding pipes before we can start making some data pipelines. Look at these 2 lines of code. Okay, it's a filter command that we kind of talked about before. Here's what we typed before. Here's the R code where we can accomplish the same thing using pipes. Okay, these pieces of the code do exactly the same thing, but they're a little bit different. Can you see what's different from there? I'm going to fast forward. Essentially, what the pipe operator allows you to do is take the first argument of these dplyr verbs. And remember, I told you that the first argument of these dplyr verbs always have to be data frames. Essentially, it allows you to take this data frame, stick it on the front, add this pipe command, and then use the rest of the filter command, but you don't use the input data frame because we moved it to the front. Okay, and you'll see why this is pretty cool shortly here. But it's just another way to write the same exact kind of code, but this turns out to be very useful. So let's take a look at how the pipeline operator could make a data pipeline. So Remember, a data frame and a verb produces a modified data frame. But remember, the input to any verb is always a data frame, so we can easily pipe that into another dplyr verb with another pipe to produce another data frame. And so the idea is that we can chain these verbs along, passing a data frame from verb to slowly manipulate it and do some math to get it into essentially the end state where you want to do to get to your data analysis. Okay, so there was a lot to unpack there. I understand that, but just bear with me here, and it might take a little bit of additional work on your own to sort of review this information and make it stick. But let's say we have a dplyr pipeline here where we want to first only get the rows of our table where the bioreplicate has a value of 2 or higher. Then we want to count the number of runs that are present per condition. Okay, so we're filtering things out. Then we want to count up the number of things per condition and then order the results in descending order. Okay, again, this is a little bit of a contrived example, but just bear with me here. Here's what that dplyr pipeline would look like. And in fact, let me just grab this code and we can paste it here so we can see what it looks like. So a couple things with these dplyr pipelines, oftentimes you see these new lines that occur after the pipe operator. That's completely legal and frankly makes things more readable because these pipelines get very long and they flow off the screen. So you can put new lines after the pipe operator just to pretend like it was on one line. Okay, so let's take a look at what happens here. Remember, we have our data frame here. If we're going to filter this by the bioreplicate equals to 2, let me copy and paste this. Greater than or equal to 2. We filtered out all the bioreplicates equal to 1. Okay, and this is a new table. This operation is going to pipe this new table that we just created into the next command, which we're going to group by the condition. So let's run the pipeline up to there. Now we have a new table where we've filtered out the bioreplicates that equal to 1, and now we're a grouped data frame. We can summarize that by getting the number of runs per condition by using the length command. This is what we learned before on the number of runs. So let's take a look at that. And it tells us that there are 3 runs for each of these conditions. And then, I don't know, for the sake of it, let's just order these in descending order of the condition. That's going to be an alphabetical sort. So let's run that. So now we've reordered this so condition 4 is on top because we're going in descending order and we know the number of runs for each data file. So imagine, again, let's say you have a proteomics data set and you want to count up the number of peptides or proteins that you detected per MS run. You could do that using a dplyr pipeline just like this, where you can sort of group by the proteins, count up the number of peptides. You can order by the number of peptides that you do to see what your top number of sort of sequenced proteins were, and so on. So these kinds of pipelines are really useful. And let's come back to the code here. I mean, the code almost reads how you might describe this in English. Essentially, it's like, take the data, and then I want to filter it so that the bioreplicate is at least 2. Then I want to group by the condition and count the number of runs per the condition. Then I want to arrange that in descending order. I mean, it's almost like the English way in which you would say the code corresponds to how you state the problem of the code. And that's really cool about these dplyr pipelines. It's like, if you can say it in English, the sort of code kind of falls out for you to a certain extent. Again, this is an advanced topic. Definitely, it's going to take some practice to do and understand, but it's really powerful.
Ryan, there's a question too about the data frame.
Yeah. Let's see. So, okay, so let's see. So the data frame is now okay, thank you. This is great. So the question is, the output of this pipeline, did we modify the original data frame? And the answer is no. R usually does not modify the arguments of functions by and large. Lots of other programming languages do that, but you should almost always assign the output of all your hard work that you did in the pipeline into a new variable. And you know how to do that, right? We've been doing that over and over today. So we can just assign the output of that to a new variable, and mod dat 2 has the results of that. Great. Okay, so that was it. Okay, So I think that covers it. We're sorry, 7 minutes behind, but I think hopefully we can do the recap at the end. Okay, so just the high level ideas here. We talked about fundamental data manipulation operations. We talked about how the dplyr package implements these operations as data manipulation verbs or as functions. We showed how we can use those functions and actually pipe them together in ways to answer questions about questions about the data that you want to answer, and that it's really cool because it's often very human readable in the way in which it works. Again, this is complex, definitely the most complex thing we covered today. It's definitely worth your time to go through, I'd say, the examples to really understand this, because I think it will open up lots of possibilities for your data analysis work. Okay, so that wraps up this section. Pretty dense. Thank you for sticking with me. Let's send everybody off to their TAs. If we go to our workshop, there's one last set of exercises. This might be the most advanced for you, but it's module 6, I believe. Yes, I think it's module 6. So anyways, let's go to your TAs. You're going to be working with the same data frame that you worked with on the last exercises, so that won't be new, and maybe just go through the questions and try to work through those. So let's come back 11, 12, 1, 2. It's 2:48. Is that right, Olga?
Right now it's 2:48, yes.
Okay, let's give 20 minutes because I think it's worth it, the worst to practice. So 2:48:50. Let's come back at 3:10. Is that right? 48? 3:10. And we'll do a quick wrap up in about 5 minutes, if that works. So great. Let's go exercise.
Thank you.
Thank you. Right, it's getting close to 3:10. We were scheduled to go to about 3:15 Eastern time. We've covered the content portion of the class, and please, if you're working, feel free to continue working with your TAs here until the end. I just wanted to cover a few closing remarks and maybe pass along some resources that you could use on your ongoing journey of learning R. So we'll give it about another minute here, and then we'll quickly go through that. All right, it's about 3:10 here. So I just wanted to have a few closing comments, a few closing notes. First of all, big thank you to everybody here who's attended. Learning a new programming language, particularly from scratch, is not an easy thing to do. In fact, it's really quite challenging. You know, I think back to my early days of learning R, and it was really hard and sometimes frustrating. That's sort of part of the process of learning something of value, I would say. And even if some of the material was a little quick or maybe difficult to digest, I would please really encourage you to keep at it, because I think you'll find it's a really useful skill to have. And even if you don't become, let's say, an expert data science, there's sort of a level of proficiency that you can get where you can start doing some really basic but powerful analyses with your own data. You don't have to rely on other people or other pieces of software to do that. So I very much encourage you to stick with it, even if maybe some of the things were a little bit quick. Here. And again, we have these resources online, access to the slides, the exercises. I will be posting the solutions later today on the GitHub site, so you can go and look at those to follow up and practice on your own. Okay, so let's just have a few closing thoughts about what we covered and learned today. So we talked about using R and RStudio. We learned some basic syntax. We worked with vectors and data frames. We did operations on them. We talked about how to read data into R. We did not talk specifically about tidy data, but you can maybe look at some slides for some ideas and context on that earlier up in the slide deck. And then we also recently just talked about how we can use dplyr to operate on data frames and make these data pipelines. So I would be very happy if you could answer yes to almost all of these questions here. So are you now able to start up RStudio and make an RStudio project? Can you create a variable? Do you know how to do that? Make the assignment? Can you make vectors? And can you work with them? Maybe find out how many values are there. Maybe do statistical summaries on those, like the mean and the standard deviation and so on. Are you able to read a CSV file into R? What about some of the basic properties of a data frame? How many rows and columns it has? How many unique values of a certain column are there? We didn't cover, again, the tidy data question, but you can take a look at that on your own, and then also get a hint about performing data manipulations using this dplyr package. I certainly understand that that was probably a very complex section and a lot to digest there, but hopefully with some of the examples and just spending some time in RStudio with the code and running the examples, that things will start to make more sense. Let's see here, we have a question. Yeah, so the question is, how do I get the answers to the exercises? What I'm going to do is later this afternoon, I don't know exactly what time, but I will post them to the GitHub site. And let me just be very explicit about this. So in various emails and so on, there was a GitHub site here, a link to the GitHub site here. Shall we post it again in the chat? I think I'll do that.
Sure. It is also posted on the ASMS website, by the way.
Great, it's everywhere. Okay, so there we go. Go to the workshop. You're going to go to exercises. You're going to go to day 1, intro to R. There are 3 R files here. There are going to be 3 new R files that are going to appear here in a couple hours here, and they're going to have solutions at the end of the file name, and those will be essentially my solutions to these exercises, so you can look at those. So thank you for that question. let me leave you with some resources. There are a ton of R resources out there. Just go to Google and R and Google for R and so on. But I think a couple of places to look is to look at the RStudio website. Let's actually go there. If you go to resources on the rstudio.com website, there is an education section here. And there are all kinds of resources here that they've compiled here that you can learn about using R, and they have some nice tutorials in here, cover maybe lots of things that we covered. And so you could go here sort of on your own time and really just, you could spend days or months here going through all this kind of stuff. We talked a little bit about the tidyverse. We didn't have too much time, but this is a really, I think, a really pretty amazing way to work with data in R. And it's worth learning more about the tidyverse. ggplot2, which we're going to learn about tomorrow, is part of the tidyverse. dplyr, which we worked with, is part of the tidyverse, along with a ton of other packages. There are 2 online books here that are really good. They're free as well. So this hands-on programming with R is designed for people who are coming to R with little to no programming background. And so this might be a great starter. If some of this material went a little quick for you, this is a full, thick book that talks about working with programming in R. Garrett Grolemund, he works at RStudio. He's a great educator, does a really good job. And this is a free book all online. You could go through this and really learn a lot by going through the book. This other book, R for Data Science, I think is a must read for anybody that's doing working with data in R. This is maybe slightly more advanced, but I don't think it's necessarily out of the question. You could go through and run the code that they have in here. And it takes the whole data analysis pipeline from reading data in to visualizing the data to doing the dplyr kinds of operations that we are doing to working with messy data and making it tidy and so on. Essentially, all the things that we touched on today are covered in this particular book, obviously in much more detail, written by the author of the dplyr package, Hadley Wickham. Hadley has also written the ggplot package. He is a huge luminary figure in the R community, and this is sort of his official book about working in the tidyverse. Highly recommended, and it's online and it's free. It's great. There are lots of people that we can follow. I mean, obviously all of our mass spec people, Olga, Mina, and all of her team, they are great people to follow sort of in general about what they're doing and their work in the mass spec space. Certainly recommend them. In the more general sense here, we have some specific people for more on the general data science side of things. So Hadley Wickham, like I said, he is the author of the tidyverse, core tidyverse packages of ggplot2, of dplyr, and all these things. He's just a really big figure in the R community, a great guy as well, very dedicated to education and helping people learn R. So anything by him is a great resource. Jenny Bryan is another amazing educator in the R space. She works at RStudio along with Hadley Wickham, and she's really a great educator as well. Julia Silgi, again, these are all Twitter handles. I follow all these people. She's a great data scientist. She's worked at a variety of places. She's also working at RStudio now, but great to follow. Mara Averick, she posts a lot on Twitter. She's great for learning about new things about R and new developments in R. She tweets about all kinds of stuff though, so you kind of get a mixed bag with her, but she's really, really great to learn about interesting things in the R community. David Robinson is another figure. He was doing things for a while on Twitter called Tidy Tuesday, where he would take a data set and live code his analysis of it. And he uses sort of the tidyverse way of working with the data, but it's really enlightening to watch an expert like him take a data set, ask questions about the data, make plots, make visualizations. So look up David Robinson, Tidy Tuesday. Lots of really great stuff. You should see some videos on YouTube about that. You can follow these hashtags on Twitter. That's helpful to learn more. I have some thoughts about where to get help, but you can read that. Sort of last but certainly not least, we have this huge list of TAs that are really helping behind the scenes to help make a workshop like this actually work and try to help people behind the scenes. It's very challenging in a virtual environment to offer this kind of class, and these TAs are offering their time to do this. I can't thank them enough for all their hard work. As Olga mentioned, a video of the presentations will be available on YouTube here, which is cool. So you can go there and watch this material, particularly if it went a little fast for you. You can go and watch these videos. Olga, is there a time period under which these are going to be up and down, or are they sort of going to be perpetually up on YouTube?
We will leave them up. So as
Yeah.
soon as Zoom finishes processing, we will upload hopefully later today, and we will leave them up as one of the playlists under the Main Institute channel.
Great. Yep. So come there, watch to your heart content, or use it to go to sleep at night, or however you'd like to use it. But in any case, it'll be there for your reference. So anyways, thank you again for sticking through it. This is a challenging process. Please do not feel frustrated. It's difficult to learn a programming language. Thank you for sticking through it. And again, all this effort will be worth it in the end, and wish you the best. Obviously, we're here. We have 3 more days to go through, and looking forward to continuing to work with you with the rest of the workshop. So thank you.
Thanks
Olga, do you
so
want to say
much.
anything?
Yeah, so well, first of all, there is a question. Is the course constructed in a way where we build on the information from day to day? Somewhat. So tomorrow our plan is to work with ggplot, and obviously the topics we discussed today are very important for being able to work with ggplot tomorrow. And we will try to reuse the same data as much as possible. However, Kylie has her own way of kind of presenting things, so there will be not quite exactly the same, but there will be definitely, it will be definitely useful if you can go over the materials today and become really comfortable with they for tomorrow. Yes, tomorrow's workshop will be recorded same way, so we will be recording that. And so if you have any suggestions to us, we would actually very much like to hear from you, because as I mentioned in the beginning, we have not yet done a course with such a kind of substantial hands-on component and TAs. So we would like to hear from you what was useful, what was not useful, because chances are we will be doing this again, and we would like to learn from this experience, but also to improve, the remaining 3 days that we have, especially for the last 2 days. We have a whole week in between. We can realistically make some changes if needed. So is the RStudio Cloud Base still active after the course? That's a question to Ryan.
Yeah, the answer is no, and mostly because there's a cost associated with the hours that we're using here, and we've sort of budgeted a certain amount. And when you have 100 people in the course, actually those costs kind of go up. So after the course, we're going to take it down. I'm going to post some additional information on our GitHub site about installing R and RStudio on your local computer. Please check on that in the next several days, and please try to go through that to get a working version of R on your computer. And you can actually contact me if you need to. I think my email was in one of the other emails address. Feel free to reach out to me if you have any questions. I'm probably opening the floodgates, but I'm really want to make sure that people can get a working instance of R on their computer, and want to help as much as I can. So.
That's right. And let me maybe add that ASMS kindly funded the computer time on RStudio Cloud. Yeah. So that was very helpful. And let me read one feedback right now already. Thank you. This workshop has already been super helpful. TA time was absolutely wonderful, says Nancy. Thank you very much. Really glad to know that TA time was helpful.
Great.
Okay, so we will see you tomorrow, so noon Eastern. We will have the same setup, so there will be some discussion in the main lecture and some TA breakout rooms. Starting tomorrow, there will be no separate quote-unquote advanced groups, so everybody will be in the same place. Okay, thank you a lot once again very much, and we will see you tomorrow.
Thank you. Bye.
So Tamara left already. There was still one question. Okay.